Hello everyone. In this how to make my first Unity game tutorial, we are going to take a look at the Unity interface, how to get Unity up and running, as well as some simple game objects. Before we get into it, remember to subscribe to see more and hit the notification bell to be notified whenever I upload. It really helps me out. Now, on with the show. So what is this series all about? This series is all about taking you, the person who is new to Unity, and building your very first game. You'll be learning tons of different things throughout this series, including coding, including design, and many more things about the Unity engine itself. So where do we go from here? Who is this aimed at? Well, this is aimed at many different types of people, but primarily it's aimed at people who are fairly new to Unity or perhaps brand new to Unity. By the end of this series, you will be able to consider yourself an intermediate developer within Unity. So realistically, this series is designed with you, the viewer, in mind. And the great thing is, you don't actually need any prior knowledge in Unity or programming to get started with this series. I will teach it all to you. So, the series will work in all versions of Unity as long as you have something from at least 2015. Some menus may look a little different, but if you're using a different version to me, things may be moved around a little. If you get stuck or anything, please leave a comment in the video that you're stuck on, and I will be able to get back to you. If not me, somebody from my fantastic community will be able to. So, what are we going to create? Well, we're going to create a cool little game that you've probably seen in the thumbnail of this video. By the end, it will look something similar to this. So, let's get into all of this. Right in front of us here, we have the Unity Hub, and this is more than likely what you will see first and foremost from Unity. You'll download this, but you may not see all of these installs. How do you get Unity onto your machine? Make sure you click Installs down here in the hub. Then you can click on Add, and it will present you with a couple of options of what you can install. I would recommend one of the latest official releases, possibly one of the most recent ones. You don't want to go too far back. 2018 is a good version, but you may want to use 2020 if you're in 2020. Even if you're in 2021, you perhaps would want to use that. I would avoid some of the pre-releases just in case. They can tend to be a little bit buggy. Once you've selected your version, you just need to click Next and follow it all the way through, and it will eventually install here. Once you have your version installed, you will be able to go to Projects, and you should be able to click on Add or click on New. So Add, if we go there, will actually bring up your first game. See where you can add a project if you already have one. If you don't, you would just click on New, and you'll be able to add a brand new project. And realistically, all we need to do at this point is to select your project name, so you can name it there. Make sure we have 3D selected, and then you can select the location of where you want to save your project right there. Once you've done so, click on Create. Once you've clicked on Create, you'll be presented with this. This is the Unity engine. So I'm going to briefly go through a couple of these windows that we can see in front of us. Don't worry if you find this too vague. We will go through them a little bit more as we use them in a real development environment. So let's start with this one over here. This one is the hierarchy. Now the hierarchy is basically just a way of showing what game objects you have in your current scene. What is a game object? Well, a game object is anything that you would see in this window here. This is the scene view. This is where we build everything within Unity visually. So if we have some models, some objects that we want to bring into Unity, you will be able to see them right here. Now, there are a couple of other windows also attached to this depending on what your Unity looks like. You may have a couple more up here. I only have game at the moment. The game view is a way of actually playing the live game itself that you have built in the scene view. So, for example, if we have an area that we have a player wandering around on, we can actually play that game inside the engine rather than make a standalone build. And we can achieve that effect just by clicking this play button up here. It will go slightly darker, and you will go into this right here, and you'll be able to play whatever you have built. Obviously, we do need to build a couple of things before we can play it realistically. Over here we have the inspector panel, and at the moment the inspector panel is completely blank. However, this is where interaction between these panels now starts to come into effect. We can click on Main Camera and we will see things appear here in the Inspect panel. All of these represent something known as components within one single game object. So we have the main camera game object selected, and we can see all the components attached to that game object. Because this is a camera, we would expect to see a camera component. And we always have this transform component on any game object. The transform component is basically just a way of the object knowing where it is, how it's rotated, and how big or how small it is. All of this is determined by an X, Y, and Z or Z coordinate right here. They can be changed if need be. And as I said earlier, this is a camera component. There are many hundreds of types of components within Unity. You probably won't use them all. You probably don't know them all, I would say, because most of the time, one single project will not use every single possible component. Components serve different purposes for different game objects and for different project types. If we were to click on the directional light, for example, we can see that there is a light component attached to it. So everything that we would need to control a light source within the scene is right there for us. Down here, we have something known as the project window. The project window is where we store all of our assets. What is an asset? Well, an asset can be anything that we use to create a game with. It could be a texture, it could be a game object, it could be a script, it could be an audio file. So anything we would use to develop a game is classed as an asset. In fact, this here is a scene, and even a scene is classed as an asset. If we were to go into this scenes folder, we will see here this little icon, and this little icon is the scene we are in. So if you want to build different levels, different areas, different segments, you would use different scenes. So we would build something within a scene. Now, next to this, we have console. The console is where we're able to see basically a breakdown of what is happening, or perhaps there could be an error in some code of ours. We would see it here in the console, and it will give some indication of what the problem is, what we can do to resolve it, all things like that. So the console will come in very useful. So those are the basic windows that we'll be using within this series. We will probably add a couple more as time goes on, but I will explain those even more as we get further in. The next thing I want to explain is something known as the build settings. So if we go to File and go to Build Settings, we can see here that we get a little pop-up window. This little Unity icon determines what platform you are currently building for, and at the moment we are in PC, Mac and Linux standalone. We can also develop for Universal Windows platform, iOS, Android, PS4, Xbox One, and most likely, because I'm not quite at the point where the PS5 and Xbox Series have come out yet, we will be able to put those there as well when support is released by Unity for those platforms. So whatever platform you want to build this game for, you would select here. You can change the target platform at any one point throughout the game. However, I do recommend the earlier you do it, the better. The reason being is because the shorter amount of time it will take to convert the platform. So for example, if we want to build for Android, we can select Android and then click on Switch Platform, and it will switch the target platform to Android. This doesn't mean that you are permanently stuck developing in Android. You could make your game completely in Android platform and then switch back to PC, Mac and Linux, and then you could build it for PC, Mac and Linux as well. So build support for all of these devices, all of these platforms is entirely up to you. However, you do have to remember that sometimes you may need a license. This is the case with at least the PS4. So Unity is object oriented, but that doesn't mean there isn't just as much coding. You've got to always remember that. I'm just going to close this window down now. So when we speak about objects, what do we mean exactly? Well, the most basic object within Unity is a cube. So let's bring a cube into our game. So let's click on Game Object at the top, and we are presented with a menu of various different types. And the one we want to aim for is a 3D object, cube, and this will be placed inside your scene. So What does this mean? Well, realistically, it means that if we go to the game view, we can now see an actual game object in our game. And I know for some people this may seem a little bit simplistic, a bit plain, nothing exciting about that. But for those of you who are brand new to game development, that is a revelation. You've managed to insert a game object into a game already. So let's actually reposition this cube. Remember earlier I spoke about the transform component up here? Well, at the moment it's stuck it in a random position. The center of any scene is always going to be 0, 0, 0 on the X, Y, and Z coordinates. And that is the center of the scene. So let's take a look what we can do with this. Did you notice how I managed to quickly look down at that cube? What I did was I held down my right mouse button and I dragged the mouse so I could see and look around. You'll notice that we can change that to an eye icon and we can pivot around as such. The left mouse button will select things within the scene, so we can physically click any objects within the scene itself, like so. The mouse wheel allows you to zoom in and zoom out. And if you click the mouse wheel and hold it down, you can actually pan around like so. All of those options are relatively simple to use, and they do have a couple of different ones up here. We have the hand tool right there. We have the move tool, which is what I do have selected to do everything with right now. We do have a rotate tool, which allows us to rotate game objects. And you can see if I hover my mouse over certain places of this rotate sphere, we can see that's how we rotate it. And I've just held my left mouse button down, and you can see the light source rotating and changing how it looks in the window. Let's hold Control and press Z to undo that and reset it. Next, we have the scale tool, and this allows us to scale the size. Now, things like a light source won't matter when scaling because they are singular. They exist just on one plane of existence. Something like a cube, however, is a little different. We can change how big it is by using the scale tool. So now let's undo that. We can also use the rect tool to do pretty much the same thing. However, the rect tool is designed for more of a 2D view. So when we come to designing some UI elements, some on-screen text or imagery, we would use the rect tool a little bit more. And we also have the, what I like to call all-in-one, which gives us a bit more convenience around changing objects. So it's worth playing around with some of these tools just to kind of get your feeling, your grips, your bearings with Unity and all of its tools. So remember I spoke about this cube earlier? Well, let's hold down that mouse wheel and get it into view. Let's select our move tool, and now let's play around with the rotation. So we could type a rotational number here, so let's say 45 degrees, or we could hover our mouse over either the X, Y, or Z, and we can change it by holding down the left mouse button and moving like so. So we can do that on any axis, any at all. And we can also do that with the scale. So we can change the scale exact same way. So now we have the kind of Unity imagery that it has there. That whole kind of shape, you know what I mean. So what I like most about how all of this works is the simplicity of Unity in itself, and it is a fantastic application to use. So if you are a beginner to all of this, I would recommend playing around with some of these objects. This is just one simple object, and let's say for example if you have gone too far, you've modified it way too much, you can always click on the component up here, click the dots and click on reset, and it will place it back to its original form before you started making modifications. So now we have this back to normal. So let's save our scene as it is now. So let's hold Control, press S and save that scene. We're still in that sample scene, so that's all good. So up until now we have learned pretty much the basics of Unity. We've added a game object. There are other game objects that we can add in, whether it's a light source, audio, UI, more 3D objects, and we probably will delve into them a little more in the next tutorial. But for now, as long as you are happy with how Unity is for you, how it's laid out, if you're comfortable, you can probably move on to that next tutorial. If not, play around a little bit more, explore different options of all we've seen here, because we've only explored the very basic options. Basic is all we need at the moment for this series, but we'll get into more as we go further along. So a material is basically a way of applying a colour or an image to objects or models inside the Unity engine. So for example, we have this cube that we placed here from the last tutorial. Let's actually give this cube some colour rather than the standard white. Now, one thing we can do is we could use a texture and apply a texture to it, but let's create the material from scratch. So firstly, let's create a folder which will allow us to store all of our materials in. So let's go to Assets here in our project window, and we will be at the default top level. Let's right click, and we can see the word Create at the top with another menu. We have many things here, some of which we will be using at some point, but we want the top one, which is Folder. Let's call this folder Materials. So any type of material that we create will be placed inside this folder. So let's go to that section down here, right click again, create again, and you'll notice about a third of the way down you'll have material. When you click it, you can name this absolutely anything you want, but we should probably name it something relative to what we're creating here. Let's call this red material. Hit return, and you'll see the icon turns into a white orb. Now, we can change this material, the color and scale and all kinds of things right now, or what I've always found the best thing to do is apply the material to the object first and then modify the material. That way we're able to see things change in real time. So I'll explain and demonstrate why I think that is the best thing to do. So we're going to take a look at this option just for now, and this albedo option here is the color of the material. So let's select this here and change the color to red, and then close. And you'll notice that, yep, the material has indeed changed here, but because we haven't physically applied it to this object, nothing will ever happen. So for now, I'm going to undo that change to red, and then I'm going to drag and drop this material onto this cube right here. So hold down left mouse button, drag and drop onto the cube. You can also drag and drop onto the same object inside the hierarchy. The same effect will occur. It will be on this cube now. And if we click on the cube, you'll notice down the bottom we have a couple of different components, but we now have the material component attached. That means that whenever we change this material, it will update this object real time. So let's click on our material once again. Let's go to this albedo option again, and let's change it to red. And you'll see that the cube changes exactly the same time that we change to red. Now, there are a couple of different options that we have on this material. Not all of them are going to be relevant at the moment. I think more than anything, it just depends how you want your material to look. We could make it slightly shiny. We could make it plain, flat, simple, and plasticine. It's entirely up to you. So I do have another video going into much more depth on materials, so I'm not going to go too in depth here, but I'm going to give you enough information to fully understand what a material is. So the options that we are going to use are albedo. We're able to change the color. We are also able to apply a texture, but we're not going to do that this tutorial. We're going for just a simple look until we're ready to really apply more assets. We can change the visual image of this material in the metallic and smoothness sections. So if we were to increase the metallic look, you should be able to see that this does indeed look a lot more metallic. Because it's red, it's deeper, and we can really see the metallic look within the icon of this material. If I set it back to 0 on the slider, we can just see it does look plasticine. But metal has more of a tendency to shine in certain spots, and we can see here and here that that really is the case. We can also change just how smooth it is, And once again, we can see just how shiny the material does indeed appear. Now, if we pan our camera around and look at our cube, we are not going to see much of a difference at the moment. Reason being is because there isn't exactly a whole lot in the scene to cause any kind of reflection, and simply the size itself is rather small. So I do intend to use this object as some kind of ground level. So let's change the scale to be somewhat larger than what it is, so we've got somewhere for our character to eventually walk around on. So let's change the scale to 20 on the X, and let's also change it to 20 on the Z. And we now have a large square that we can walk around on. So what else can we do with this material? We can change the source to either metallic or albedo. And obviously, depending on what you want your game to look like, these settings will be quite important. We can see just how intense the red can be just by changing some of these settings. Now we have the very simple plasticine look, and setting it to metallic and working those around, we have a much more deeper look. So I would probably recommend playing around with some of these at some point to at least illustrate how you want your game to look, whether you want it shiny, plasticine. I know a lot of people do like that very simplistic look, and I think I might actually go for that slight look about there for now. So coming back a little bit, if we click on our directional light, and do you remember last tutorial we played around with the rotation of that light? Well, we can do the same now, and you can see just how much it does indeed impact that material. So if I reset that by holding Control and pressing Z again, let's actually set that material back to metallic alpha, and let's bring those values right up to the top. And if we go back to our directional light and move it around, you'll see there is no impact. So you have to keep in mind that depending on what you want to do, it can take some time for your material to actually physically, in inverted commas, update on how it looks, because you cannot simply just do that, move your camera, your light source around and expect instant results. You would have to let it just kind of process. So that is why you would not see any results when you change your light source as such. There we go. So I'm going to reset that back to its original value of 50. And I'm going to change this material back to roughly what I had it before. Let's have it about there. So another way that we can modify material is on the object itself. So if we click on our cube and go down here to the bottom of the inspector panel, we can actually change the exact same settings right here for our material. You just have to keep in mind that even though you're changing it on one single object, if that material is attached to any other object, then it would also make changes to that object as well. So when you're changing things here, you're not specifically changing the object itself, you're changing the material. So we can see, change it there. That is how it has an impact. So as I said earlier, best thing to do at this point is play around with these first few settings to get a nice color of what you want on there. If you have the knowledge already and would like to apply a texture, you could always go ahead and do that. But we don't actually need a texture on here right now. So let's go a little further with some of this material and object business, shall we? Let's create another object and create a different material. So let's go to Game Object, let's go to 3D Object, and let's go to Cylinder. Now I want this cylinder to end up a bit like a coin. So I can actually modify the scale of this to get it in accordance with what I want it to look like. Firstly, let's set the position as 0, 0, 0. We now have it center of our scene, so we have a good way of seeing where it is. So if we zoom in with a mouse wheel and pan up, we can actually change where we want this to be, how we want it to be rotated, and its size. So let's change the rotation by 90 degrees on the X, and that will place it about there. Now we can always bring it out there. You'll notice that it does indeed collide with the floor, but we don't need to worry about that for now. We can just basically pull it out of the floor to about there. So we need this to be a coin shape. That means we need to change the size of the scale right here. And we can change this by going, let's say, 0.3 and 0.3. Now we need it to be extremely thin. So we need to change this one from probably probably 1 to about 0.1. That's still too big, I would say. So we could go a little further. I guess it depends how big you want your coin to be. Or you could change the scale of this and increase the size. So now it's a rather thick coin. Let's decrease this one more time to 0.05. And I think that should do for about the size of our coin. Of course, it doesn't look much like a coin at the moment. It just looks like a white dot on a red background. So let's create another material. Or let's duplicate this material and change what we need. So here's a little trick. If we click on the material we've created, hold down Control and press D, we can duplicate that material. And what it will do is it will give it the same name, except it will put the number 1 after. So we can see here, red material 1. So let's actually rename this. So we can right click, rename, and let's call it yellow material. And now let's drag and drop, even though it's still red, let's drag and drop that onto our cylinder inside the hierarchy. Right there. So now what we can do is let's change the color from red to yellow. So hold that, yellow, and there's our yellow coin. So it's still working in the same way that the red material is, it's just now yellow. And remember that little trick that I just showed you, holding down Control and pressing D? Well, that can also work on game objects as well. Let's select that cylinder in the hierarchy and let's do the same. Let's hold Control and press D. We now have another one of those. However, we don't see it in the scene. The reason we don't see it in the scene is because it has duplicated itself in the exact same position as our previous coin. So in order to get that out of there, we can just drag, and there is the split. We now have those two coins, and we can do the same again if we want to. We can duplicate and bring out another coin. So it's a nice, quick, easy way of recreating the same object multiple times. So let's play around with some of these settings. Let's change this position so it's exactly 1, because it is ever so slightly over 1 on the y-axis. So let's change that to 1. Let's take a look at this coin. Let's change this to 1.5 and also 1. And now let's change this to 1.5. Let's change this to 1, and let's change this to -2. So now they are in a much more easier position. What if there was an easier way of doing that? Well, in actual fact, there is. Let's duplicate this cylinder by holding Control and pressing D, and we can use something called snap. And what that will do is it will move any object in a specified amount each time. So if I hold Control and move this object this way, it will move it in increments of 0.25. Now, your settings may be slightly different. They may be 1, they may be 0.5, they may be 0.25. If we go to Edit, we can actually set a couple of things here. There are many, many options, and I may go through a few as they stand right now. If we go to Preferences, you can see that there is many, many different things here. A lot of people do get mixed up with the preferences and project settings. I do think the preferences at this point are something that we don't need to worry about. But generally, you could go through if you wanted to. In the project settings, you have a similar sort of feel. You have many, many, many different options that you can go through. And a lot of them are something that we probably will go through at some point. Anyway, so all this comes down to the grid and snap settings. So you will often find that settings within Unity are not misplaced, but they can be a little bit confusing to find. For example, I'm not sure why grid and snap settings were ever their own separate settings and why they're not in anything else. But either way, if we go on grid and snap settings, we have this little box here. And this little box gives us the opportunity to change what the increment snap is right here. So, like I said, mine is set at 0.25, but you can change this to whatever you want it to be. So if you want it to be 0.5, you would put 0.5. And that means that every time you now move this, it will move in increments of 0.5, which we can see right there. So you'll find the snap settings to be very, very useful. I can't tell you the amount of times that I have tried to move objects and they haven't moved correctly. So as explained in the last tutorial, coding can be somewhat problematic for some people who are brand new to it, but rest assured, everything I teach in this series when it comes to coding, I'll explain. So what we need to do in this tutorial is, as these are going to be collectible coins in our small game, we need to have them rotate or something like that. So we're going to create a script which will allow us to attach to this coin and it will rotate when we run the game. So let's create a folder where we can store all of our scripts. Let's go to our top level assets in the project window, right click, create, folder. We'll call this scripts. And in here, let's create another script which will allow us to make that rotation. So right click, create, and you'll see the second option down is C# script. Let's click that, and now we can type the name of our script. Let's have this as coin rotation. And you'll notice I have a capital C and a capital R and no space between coin or rotation. It's important that we remember the name of this, as it will come in useful if we ever do change the name of the script. So let's hit return. You can either double click or hit return on this script and it will open up in Visual Studio. Now you can use almost anything to write your code in. I'll be using Visual Studio as it's easy and convenient, and most people who are new to Unity will probably have this installed by default anyway. So what is all of this? All of this are the default lines of code that the script will give you when you create a new script. These three at the top are known as a namespace, and we don't need to worry about them just yet. They aren't going to be important when we are rotating any particular object. The next section below is known as a class, and almost everything we write in a script is going to be inside this class. The next sections down are known as methods, and these methods are pretty much where the grunt work happens within code. So everything we want executing in code will more than likely occur inside these methods. So we're going to do a couple of things in this script. We are going to write some code inside a method, and we're also going to declare a variable. Now, by default, as I said, it gives you these two methods, and we do not need both of those. The only one we need is this void update. So whenever you see the word void, that's a method known, or rather I should say it's known as a method. And whenever you see green writing like this, that is an annotation. This isn't a line of code, this is just a note to give some information about what a particular section does. And you can put anything you want, providing it does have a double slash before it. Now, as we are only using this void update method, we can delete these lines between the two green sections because we don't need this void start method. So we can select all of that and delete. What we do need, however, is a variable. What is a variable? In its simplest terms, a variable is a way of storing information in a script which can be changed and or modified at any given point, either by the script itself or by a different script. We can also set that information ourselves at any given point. So we are going to use a whole number or an integer as a variable here because we want to be able to possibly change that number at any given point. Now, to declare a variable, we have to type the word public and then the type variable. In this case, it's going to be an integer. And to declare an integer in C#, you just type the letters int. Obviously, that is short for integer. After those two, we now need to put whatever we want as the name of this variable. As long as the variable is named something sensible and relative to what you are creating, then you're not going to have too many problems. So for example, we're going to have this as rotate speed. And like I say, you can call this anything. You can call this purple card if you wanted to, but it wouldn't make sense because it's not a purple card, it's a rotate speed. But it just illustrates the fact you can call this anything you want, as long as it's not the class name, the script name, or any method name. You can't call it that. So rotate speed is just fine for now. And you'll notice that I have used all lowercasing on that line of code apart from the S on speed. So the name of your variable doesn't matter on capitalization. However, the other two sections do. Capitalization is important when it comes to C# coding, as some things can mean different things depending on whether they are capitalized or not. So when we come to say public int, all of those have to be lowercase. So once we've named our variable, we have a semicolon at the end. And that is just basically a way of the script realizing that that's the end of the line. Let's move on to the next line of code. So let's hit return. So we've now declared our first variable. By default, because we've not said it is equal to anything, it is going to be equal to 0. Now we could logically add that to the variable declaration, but for now we're going to see how all of this has an impact on the script itself when it is applied to a game object. So like I say, we want this to rotate our coins. So we need a game object to rotate around itself, presumably on the y-axis, because that is the vertical one. So update is called every frame. So we want this coin to rotate constantly every frame. We don't want it to just rotate once and then stop. We need it to constantly rotate. So we do this inside the update method. And the way we do that is we play around with the transform component of the object. So if I go back into Unity and I go to our cylinder, which is this coin here, we want to rotate on the Y here. So we want to play around with this particular section here on the transform component. Oh, we want to rotate. So we can use that to our advantage. We can say transform dot rotate, because that's exactly what we want to do here. Now what we need to do is we need to tell it how to rotate, and we do that inside parentheses. So open bracket, and now we need to put a couple of values. So we don't need it to rotate on the X, so we can have 0, comma. We do need to rotate it on the Y, but we want to rotate it according to this variable that we have declared here. So rather than put a number here, let's type rotate speed. So that will rotate on the y-axis. Now, comma, we now need to put on the z or z axis. And again, we don't need it to rotate on the z or z, whatever you want to call it, depending where you are in the world. So we just put 0. And the reason we now have this next section after the Z is so as the script can recognize how to rotate this relative to the world around it. And we simply put space dot world, close bracket, and semicolon. So let's recap what we've done here. We are going to tell whatever object that this script is attached to rotate nothing on the X, whatever the value is in this variable to rotate on the Y, no rotation on the Z, and we need it to rotate relative to the world around us. So if we save that script and head back into Unity, it will take just a moment to compile, but when it has compiled, you will now be able to drag and drop this script onto these coins. So let's just start with this first coin, this first cylinder. Let's drag and drop onto there. And now let's click on cylinder, and you can see that that script is now classed as another component on our game object. It isn't on any of the other game objects just yet because we haven't applied it to them yet. However, it is on this one here. Now our rotate speed is set as 0. So if we press play, we will not see any rotation at all. However, if we start changing this rotation speed, let's have 2, you can probably see there that the shadow of this coin is indeed rotating. So what I think I'm going to do for now is bring all of these coins a little closer to our camera. And let's take our camera and let's bring it upwards so we'll be able to see the rotation. So let's go over this again. So pressing play means that we have no rotation because it is set as 0. However, if we type 1, there we go. So that script is now executing that line of code to rotate this little coin right here. And obviously, it can be rotated to whatever number you would want. You can go as crazy as you want to. However, we need to make this rotate according to the world around it. And rather than type the number, we need it to do it automatically. So let's head back into that coin rotation script. And where we've declared this variable up here of rotate speed, let's actually give it a value rather than 0. So just before the semicolon, we need to put equals 1, or whatever value you would want it to be equal to. So now we can resave that script. Let's head back into Unity. Now, if we press play, we will not see any rotation. Now, the reason we will not see any rotation is because theoretically, this script has been modified after we have made the addition to the game object. So what we would need to do in this instance is remove that component. And to remove a component, you right click on it and click on remove component. Now, if we drag and drop that script again onto the cylinder, you'll notice that the rotate speed automatically changes to 1. So just keep that in mind, that if you make changes such as saying a variable is equal to something after you've applied it to a game object, you may need to reapply that script to the game object. So now if we press play, we should see spinning perfectly. And we can attach that script to each of those coins just by dragging and dropping. And now we should see all 4 spin. Excellent. So I know at this point we are only 3 tutorials in and this game doesn't exactly look fantastic. However, you have to remember that even the simplest of games can take many hours to create. And so far this series has ran for probably less than 40 minutes. So in 40 minutes, we have this, and this is something good. So what do you think is going to happen in the next 40 minutes worth of tutorials? Could be good. So the final thing we're going to do is let's rename some of these objects, because we can't have things just named as cube. We can't just have things named as cylinder. We need relative names to them. So let's right click, let's rename, and we'll call this ground. Next, let's just call this coin, and we can do the same here. Coin, coin, and let's do the last one, coin. Now remember when we duplicated? Well, even when we duplicate now, good thing is that we will still have that rotation script on the duplicate coin. You can see it rotating just there. Let's rename that coin as well. So up until now, we have some very simple C# with our coin rotation. What we're going to do in this tutorial is a little bit more advanced, but we are going to be able to control, at least for now, a very simple game object to move around in our scene. So first things first, let's actually add in an object that we'll be able to control. So let's go to game object, 3D object, and cube. Now I'm going to set the position of this cube back to 0, 0, 0, and just bring it up to be on top of our area. I'm going to rename and have this as player. And realistically, all we need to do in its simplest terms is be able to assign the W, A, S and D keys to move this object around. Now, there are much more complicated ways of creating a controller, and we may advance this script a little further into the series if we need to, but as long as we have simple movement in place, we'll be able to have an actual game. So let's start by creating a new C# script. Let's right click, create C# script. We'll call this player controls. And let's open that up in Visual Studio. There we go. So, as I said, it's simple in terms of trying to move it around, but it is a little bit more complicated than the last tutorial that we did. But don't worry too much, I will explain everything that we need. So once again, inside the class, we do not need this start method, at least not for now. So let's get rid of it along with those two annotation lines. Now, we do kind of need a variable here. I think it's just very dependent on how quick you would like your playable character to move around. So for now, I am going to declare a new variable for this. So let's have public. And I'm actually going to have this slightly different than the last time. I'm going to have this as a decimal rather than an integer. So for a decimal, we need to have the word float. So remember last time, a whole number, integer, was just int. Well, this time, a float, a decimal number, same thing. So we're going to call this variable move speed with a semicolon. Once again, we can change this if we need to. We probably will a little later on. But for now, let's focus on getting some key inputs to move our character around. So the way this is going to work is we're going to have some if statements. 4 separate if statements to detect if we are pressing W, A, S or D. And these if statements are going to contain a line of code which will tell whatever game object that this is attached to move left, right, up or down. So let's start with the A key, just because it's the most left key of the keys we're using on the keyboard. So we need to type if, and then in parentheses, we need to establish what we want to be the logic gate here. So we need to say if we are pressing the A key. And we can use input with a capital I. Remember, capitalization is important, so it definitely is a capital I. Dot get key, and that's capital G, capital K. And now we need to say which key. So once again, in parentheses, we need to say key code dot A. And then close bracket to close the get key section, and then close bracket to close the if section, and then open curly bracket and hit return. So what we've done here is we have said if we are pressing key code A, then execute the next few lines of code. So that's going to be whatever we type here. So if we aren't pressing A, the line of code here will not function. It won't work at all. So what do we do to make this work? Well, we need to move left, don't we? So A is always to move left. And we need to transform whatever object this is attached to. So, for example, that cube that we put in is the player. This script is going to be directly on the player. So we need to transform dot. Now, this is where things get a little bit, not complicated, but different than what you would expect. The term we need to use here is translate. And the reason we use translate is because that gives us the opportunity to move according to whatever our position is with whatever we're going to tell it to move along. So for example, if we were to just say move left at X amount of speed. As long as we're holding A, that is exactly what would happen. That's why we use translate. So transform.translate, and in brackets, we now need to tell it which way and how fast. So for example, if we want to go super speed, we would set this as like 1,000,000 or something ridiculous like that. But if we want to move at a normal speed, this would just be 1 or 2 or something like that. So to tell it the direction, we need to say vector 3. And the reason we use vector 3 is because we are in a 3D environment. There is no other reason why. Shouldn't not really be using vector 2, although theoretically you could, but honestly, because we are in a 3D environment, we should be using vector 3. So vector 3 dot left, because we want to move left. And then we need to multiply that value by the time. So do you remember in the last tutorial when we spoke about space.world, because we need to make it relative to the world around it? Well, we need to make our movement relative to the passing of time. So if, for example, you think of time as a value of 1, then we need to move at real time. Real time would also be 1. So whenever we do something like this, we have to make sure that it is in accordance with the time of the game. So to do that, we say time dot delta time. And now this is where we can actually place how fast we want to move. So you can think of this as, like I said, if you want to put 1,000,000 here, you could. If you want to put just a normal number, you can. But that is what our variable up here is for. So we would multiply by that variable, which is move speed. Close bracket and semicolon to finish off that line. So let's quickly go through what we've done here. We are checking every frame that if we are pressing a key, and if that key is A, then we do this. We move whatever object that this is attached to the left in real time, going this fast. So if we set that as 0, we wouldn't move. If we set it as 1, we'd move at a normal speed. So let's set this as 1.5 as the move speed. So back at the variable, let's set this as 1.5. Now this will underline red. The reason it underlines red is simply because we need to put the letter F after any decimal number declaration in Unity, or rather C#. So the reason for that is because it's just the way it works. It's just its syntax, it's just the way it recognizes that something is a decimal number. So if you've ever typed a number that's a decimal, you get that red line, always remember to put that F after. So I'm going to save my script now, and I'm going to head back into Unity, and it is just going to compile. There we go. So now let's move this script onto this cube. And if we click it, we can see that there's our move speed. And if we press play now to go to the game view, if we press any key, you can hear me pressing keys, nothing will work. However, if we hold A, we can now move. So I'm pressing A and you can see our cube moving. However, the others do not currently work. So let's now modify our script even further to make sure those other keys do work. So back to our player control. And the great thing about this is that we can logically copy and paste and it will work. So if we take these 4 lines of code, the if statement all the way to its closing curly bracket, if we copy and paste it below, make sure we are still inside the update method, we need to change this to, let's go D with this one because we've got left. Let's make this right. Great thing about this is all we need to do is type D there. And in this section down here where we have move speed, we just need an extra multiplied by -1. The reason we have -1 there is because this all then inverts. So we're moving left at a negative speed, which would mean we're moving right. That's all there is to it in terms of math. So if I save that script now and head back into Unity, that script on the player will automatically update. So we could press play again, move left, and then move right. So all I'm doing there is holding A and D. It's as easy as that. So now let's do the final one, which is technically forwards and backwards, or up and down depending on what dimension you're looking at. So back into our script once again, and we can take those 4 lines of code once again, place them below, and this one, rather than A, is going to be W, which means that rather than vector3.left, we would change that to vector3.forward. So hopefully you guys, you've got the next line of code ready. We're going to copy those 4 down here. That's going to be changed to a D, because not a D, an S. There we go, because we already have D, obviously. And that is going to be multiplied by -1. Save the script, and that is our basic movement script. Now, it's not perfect by any means, but for all intents and purposes, it will work absolutely perfect at this point in time. So let's head back into Unity. Let's press play and move all around. There we go. That is a nice basic movement script. Now I know moving a cube isn't exactly exciting by any standards, so don't worry about it being just a cube for now. We are going to develop this a lot further, and it's going to be a nice cool little character that we're going to have wandering around. So yeah, that is our basic movement in C# script, and as I said, I do think we are going to advance that further on in the series as and when we need to, but right now, like I said, that basic movement is just perfect for us because we now have the makings of a game. We're moving around. Technically, this is a game already because we've created something that we can control. So there are many ways that you can have a camera in Unity follow the player or behave in different ways. I'm going to show you a couple of different ways in this tutorial, and you can probably pick and choose one of your own or slightly modify it depending on what kind of camera system you would like. It's actually very simple, and most of the time cameras are. So how can we get it so as this camera will follow our player whenever we move? Well, the simplest way of doing it is attaching the camera to the player itself. So if we were to get the camera, and you can see here when we click the camera we get this preview just down here. That's very handy to know. And we have a couple of options here on the component, but all I really want to do is get the camera into a position where I'm able to see the player a little better. So if I bring the camera closer, bring it up higher, and then rotate downwards slightly, we can see where the player is. So then if we attach the camera to the player, whenever the player moves, the camera will move with it. The reason is because the camera is now a child object of the player. So the player is the parent, the camera is the child, and both will move together, even though there is no script attached to the camera. Let's take a look. So there it is. So I'm moving backwards now. I'm moving across, and you can see that wherever we go, the camera is indeed following. And I kind of like that. It's simple, it gets to the point, it gets the job done. I would say that is probably the most simplistic way in all of Unity to get a camera to follow a player. And if you want that, you can just do that. But I'm going to show you a different way, which is based upon pivoting. Now, I like games where you have a character and you're able to pivot the camera and it follows the player around. Obviously, you can work with multiple different ways, advance different scripts. There's even a couple of scripts that Unity themselves offer on creating a camera that will follow a player. So again, it might be worth doing some research into this if you want to go a bit further. So let's uncouple that camera from the player, and now it is just a single object again. What I would like to do is bring the camera to the edge of our playable area, which is round about there. can see it is just above. And what I'm going to do is I'm going to make a script which will allow the camera to follow wherever the player goes. So let's right click, create C# script. We'll call this camera follow. And then let's open that up in Visual Studio. Now this is actually very simple. It's much simpler than the last script that we did to control the player, but it still works on the same principle. We need something to happen every frame because we need the camera to constantly be following the player. So that means we're doing this in the update method, which also means we don't need the start at this point or any of these annotations, so we can delete those. We do need a variable, and this variable is going to be another different one. This variable is going to be a game object, and we're going to control this variable a little differently than we have with other variables. So let's declare it public, and the type is game object, and it does need to be a capital G and a capital O there. And now let's name this something relevant. We'll have just player and a semicolon to close that out. So the idea of how this is going to work is our camera is going to be able to pivot in its position and constantly look at our player. And we can do that in a couple of different ways in Unity itself, depending on the camera position. So we're just going to write this script and use the exact same script to control the camera in a slightly different way. You'll see what I mean. So the line of code to actually get this functioning as intended is quite simply to type transform with a lowercase t dot look at, and that's capital L, capital A, and in brackets the target. So the target is going to be whatever the camera needs to focus on constantly. In this case, the player. But we can't simply just type player. We do need to say player dot transform. So the reason we have to do that is because this is working on the transform component. It's theoretically, you could think of it as looking only for a component. And as long as it focuses on the component that's attached to the player, we should be A-OK. So what this will do is it will constantly look at the player. So even when the player moves around, the camera will be looking at it. So we can save that script. Let's head back into Unity, give it a second to compile. And then all we need to do is attach this script to the main camera. So drag and drop. And if we click main camera, you'll see that extra component down there called camera follow, which is what we've just written. However, this is something we haven't seen up until this point in the series. Player, none, game object. What that means is we have to declare here what object we want the player to be. And obviously, if we put it as coin, it's not going to do anything at all. However, if we have player, whenever it moves, that means that the camera will constantly look at this variable here. So let's try that out. Let's drag and drop player there. You'll know it's worked because you'll see the little icon there and the word player. And now if we press play, we should see this camera focused right there. So let's try moving and see what the camera does. There we go. The camera is constantly looking at our player. So wherever we move, the camera is always looking. Now I kind of like this effect because it gives a bit of a difficulty. For example, if you have stuff that is a little far in the distance, it just makes it that little bit difficult, but it still works. If you've got coins over there, it just requires a bit more concentration. So I like the idea of pivoting a camera. Now, we can go a little bit further with this. If we were to bring this camera up a tad more, bring it across and pan it down by 90 degrees, we'd see exactly where our player is, and we can get a top-down view. So you can have the camera anywhere you want here. For example, let's have it just there. It will still focus on our player. So you can see how that's switched around then. So depending on how you want your player to function, you can do it this way. Cool. So I do prefer having it probably somewhere around there, maybe a little higher, and maybe rotated down just a little bit more. So it's probably at this point, it's worth me mentioning, we're now 5 tutorials into this series. You guys should be refining your game a little more than what I am. I'm obviously not rushing through these tutorials, but I'm doing things a lot quicker than what you would be doing it. So it's always wise to take your time and refine things a little more. So right now we have this awesome little game going on where we can just move a cube around, but we can't really do anything else. So what would be the next logical step for us to do? I think it would be to collect these spinning coins. So I mentioned the word tags in the little introduction here, and the reason we have to use tags in this is so we're able to define what each thing is. At least in this part of the tutorial, we just need to define that this is the player. I know we've named it player, and I know we've set a player control to this particular cube. However, we also need to be able to define it as a player when scripting. So to do that, all we need to do is head over to the inspector panel, making sure we have the player selected. And here you'll notice the word tag, and it's currently untagged. If we click that drop down menu and then click on player, that now means that we can differentiate between what is a player and what isn't when it comes to some C# coding. And you'll see the reasons why we have to use tags a little later on in this tutorial. So how do we get around to making our player collect these coins? Well, it's actually very simple, and I briefly mentioned it in the last video, and that is to use a trigger. So let's set up a script which allows us to collect each one of these coins. So let's right click, create C# script, and we'll call this coin collect, and we'll open that up in Visual Studio. So these two methods that we have right here, the default ones, we don't actually need these in this script, so we can actually delete everything. All we should have now is just this class and the namespace section at the top. So we need to create a method which allows us to create a trigger so we can collide with it and collect it. So in order to do that, we need to type void, and the method we're going to use is on trigger enter. Now if we hit return, it will automatically set it as private, and it will add these inside the parentheses. This says collider other, and what this is doing is it's creating an extra variable for us, and that variable will come in handy when we need to work with triggers. This method does not need to be private, so we can delete the word private and just have void on trigger enter. So the way this works now is we are going to write some lines of code which allow us to detect if it is indeed the player which has become the trigger. So we can use this variable that's declared here by default in the parentheses as the variable that we need. Now you can change it if you want to. You can change it right here. I'm going to leave it as default as other, but you can change other to anything you want. Just remember, if you do change it here, you will need to change it in the script itself. So to detect whether it's the player colliding, we have to say if, and in brackets, other, and remember, if you've changed it in the parentheses up there, make sure you change it here, dot tag, and this is all lowercase, equals, and then in quotes, player, and open curly bracket. So what we're saying here is if the tag is indeed player, then we execute this next line of code. And I think this script is going to be something that we will write in this tutorial and more than likely complete maybe next tutorial after. You'll find a lot with scripts. You go back and forth so many times creating and expanding and making them better. But for now, we just want the simple ability to collect those coins. So what we'll do is we will make the coin disappear from our scene as soon as we've collected it. We won't completely destroy it and get rid of it because we might be able to recycle that coin just to kind of save on resources later on. So we'll say this dot game object, and you'll notice I've used a lowercase g and an uppercase O here. The reason being is because this is not declaring a variable. If you remember that we had it in one of our previous scripts, it was a capital G and a capital O. We don't need to have that here. It's just a lowercase g and an uppercase O. I'm sure I mentioned it a couple of tutorials ago, capitalization is important, and this is why I've done it this way in this tutorial, to really illustrate the difference between capitalization. So this .gameObject dot set active, and in brackets false, and semicolon, and save the script. So realistically, in its simplest terms, that's what this script will do. It will set the game object as inactive if we collide with it. Now there are a couple of other things that we need to do to get this working, so let's head back into Unity and let that script compile. So what I'm going to do is I'm going to attach it to just this one coin for now. So I'm going to basically drag and drop this script onto our first coin, and then I'm going to tick is trigger. The last thing I'm going to do is I'm going to select the player, and we need to add an extra component to the player just so as it determines that it is a character, and the thing we're going to add is a character controller. So to do that, we need to click on add component, we need to go to physics, and we need to add a character controller right there. You could also click on add component and search manually just by typing CHAR, and it would appear right at the top. So we now have our character controller applied. We don't need to do anything else. So if we press play now, we'll be able to collect that first spinning coin. So it should disappear as soon as we collide. Now, all the other coins will not disappear, as we can see, which is a little bit of a pain, but here is a neat little trick to add the script to all of those all at once. Let's select all the coins. You'll notice that even though we have all those coins selected, we still have the option to change all of these components. If we were to select the player and the coin, we wouldn't be able to, because as it says here, components that are only on some of the selected objects cannot be multi-edited. That means because all of these items are pretty much the exact same, we're able to modify the same components on each. So firstly, let's tick is trigger on all of those. Let's click on add component. Let's go to scripts, and you can see there is our coin collect script. Nice and easy. So let's click on that, and each one of those coins will now have that coin collect script attached to it. So if we press play again, we'll be able to collect each one of those coins. Done. No more coins available. So I'm going to quickly demonstrate why it's important to have a tag here. So if we go back into the coin collect script, and let's say if the tag is equal to player 3, so obviously that tag on our player is just player, it is not player 3. So that now means that we'll be able to not collect them, as we can see. However, if we were to completely remove that if statement, it would technically work, because we're not even checking if there is a tag on the object that has collided with it. Now, although you can do this, it's not advised, because then anything that wanders around, maybe you've got an enemy or something, could pick up those coins. So it's worthwhile always having a tag check in this kind of script to make sure you have the correct thing that's collecting those coins. So it needs to have that check. And let's let that compile, and let's double check that this still works. Collecting our coins. Perfect. So what is UI? UI is a way of displaying either an image or a text or something to that effect on your screen, overlaid whenever you play the game. So for example, our game view currently looks like this, and we want to have, let's say, a score update here in the corner whenever we collect a coin. We're going to do that. So there are many different types of UI elements that we can use, and they end up all being encompassed in one single object, which is known as a canvas. So in order to get all this into place, all we really need to do is establish what our first UI element is going to be. And I would like to have just a little bit of visual imagery on there, just kind of maybe a darker box with the text on top. So what we'll do is we'll go to Game Object, we can go to the UI menu here, and you can see all these different types. So I am going to start with a raw image. Now, one thing to note about this is if we pan our camera around and zoom out, we will see our raw image right there, but you will also notice this big white block. This big white block represents where our screen would be. So these are currently our screen barriers. So if we were to have a screen in portrait mode, these barriers would be much higher and much thinner. So just keep in mind that these do represent the edges of the screen. So if we were to have this box here, we would see it directly in the bottom corner of our game view, there. However, if we were to move it somewhere here, although we can still see the full box here, we would not see the full box on our screen there. So if you want to keep your UI in bounds, just make sure it is inside this area. Now, another thing to note, we have inserted a raw image as it's known right here. However, it doesn't always have to be an image. You could use this to your advantage to create various effects, and that's what we're going to do here. So I am going to change this color over here in the raw image component. Let's turn it to completely black. However, I'm going to play with the alpha now. The alpha is a way of being able to make it either opaque, translucent, or transparent. Obviously, 255 would make it completely opaque, and 0 would make it completely transparent. Anything in between gives you some translucency. So I'm going to have this at about 50, I think. So it's very, very see-through. If we take a look now, we can see just how see-through it is. Now, we're going to layer another one of these on top with a little edge, just to give it a little bit of extra imagery, like I say. But what I'm going to do now is I'm going to use this rect tool up here, and I'm going to move this into position in the top right. So let's pan our screen around, bring it over, zoom out a little, and then we can just drag over here. Now, obviously, you can play around with this a little bit more. You can refine it with its position, its height and width, do whatever you need to. So we have it in position. I'm going to have the height, probably keep it 100 for now, and have the width as maybe, how far should we have this across? Maybe 300, and then bring it into position about there, I think. So the next thing we're going to do is actually on the canvas itself. Now, this is a little trick that I've been using for quite a while, and I think a lot of people miss this trick out, and it's actually very handy to get everything fitting on your UI perfectly. So over here, you can see where we have canvas scaler. I always like to change my canvas scaler to scale with screen size. And what this will do is it will actually scale to a standard screen size. Now, most people when developing, they aim for a standard 1080 resolution, which would be 1920 by 1080. So it's entirely up to you how you want to work with this. But generally, if you have your screen resolution or reference resolution as 1920 by 1080, that is a very standard resolution. Obviously, in the future, it's going to be a lot higher than that. It'll be 2160 at some point as standard, I would assume. But either way, if we drag this to be 0.5, you can manually enter if you want to. What you have there is a perfect balance of UI always being inside the boundaries on a standard resolution. Now, obviously, this scales. So if you were to change the resolution to 720, for example, then everything we see here would still scale. If we don't set this option, it does mean that things may go a little off screen and look a little crazy. So for now, let's realign this up here because we've set our canvas resolution. And I want to anchor this in the top right. The reason I anchor this in the top right is it means that it cannot move any further if we were to change the resolution. So like I say, if I set that there, let's make this a little longer, maybe about there. And if I go to the game view now, I'm actually able to drag this game view out of here and make it its own object. So imagine if this was our screen, someone had it at this resolution, someone had it at this resolution, someone had it at that resolution. You can see that this box up here always stays relative in size and position because of the way we set this up. It's very, very handy to know that. So let's take our game view back to our scene, and all I've done there is just drag and drop this little tab. So now let's continue with what we're doing. I'm going to hold Control and press D to duplicate that raw image, but I'm going to shrink it down a little bit. In fact, before I do that, what am I going to do is standardize the width here. Let's just have that as a standard 500. So I'm going to hold Control, press D, once again, apologies, and I'm going to reduce the width and the height so I have a space of 10 between each side. So I'm going to reduce it by 20. So this one is going to be 480, and this one is just going to be 80. And if we look at our game view now, we can see that we have a bit more imagery to this object. Obviously, you can go a lot further than that. You could change this raw image color to maybe blue, I guess. And then have a look at the game view and you would see it looks like that. You could change it to green if we wanted. And you can see just how much that does have an impact on what we're creating here. So I actually might have it a very pale yellow. So that is basically a raw image. We could attach an image to it if we wanted to. But for now, all we need to have is just that extra imagery. Let's now work with some text. So let's go to Game Object. Let's go to UI and let's insert a text box. So we can change a couple of things with this text box. Let's move it into position. And you'll notice as I move it, you'll see it snapping with certain lines. What that's doing is it's snapping it to a position relative to other UI objects around it. So at the moment, this text object is dead center of these objects here, which is very handy to know. We can also drag, increase the size, and you'll see it snap once again to various objects. Now you don't want to have it too close, so I'm going to uncouple it just there, and probably increase the size there and there. And what I'm going to do is I'm going to have the font style kept as normal. Let's have the font size as 30, and we'll see how that eventually looks. We'll keep line spacing as 1, rich text ticked, and I think we'll have our alignment kept to the, what should we have? Let's keep it left, but let's have it in the middle, about there. And others, what have we got here? We don't need to align it. We don't need overflow because I don't think we're going to go any further than that. And I think we'll change the color to a nice white. Now obviously we've got the Arial font here. We could theoretically change the font if we wanted to, and we probably will at some point in this series. For now, all we're concerned about is just getting the text in there and updating whenever we collect a coin. So I think I might increase the font size a little bit more. Let's have 36 and see how that looks. Okay, we'll stick with that. And I'm going to have this say score : 0. So we can now use that to our advantage. The reason I say that is because we can now create a script to attach to our coins. Well, theoretically, we already have the script that we can just modify. Remember that coin collect script? I think we should modify that. So the way to do this now is if we go into that coin collect script, open up in Visual Studio. Now, what we do need to do is we need to add a namespace in here to deal with any UI elements that we're going to play around with. And we are going to use some UI elements. So that means at the very top, after using Unity Engine, we now need to type using Unity engine.ui with a semicolon. And what that will do is it will allow the script to reference names and elements of the UI in Unity and then play around with them. So all we really need to do at this point is declare another variable, which is going to be that text on screen. And then we need to tell this to update that text whenever we collect a coin. So logically, what we need to do is keep count of just how many coins that we have collected. So if we now type in here, public game object, we'll have this as text score, semicolon. Next, what we'll have is public, and I'm actually going to type the word static here. The reason I'm having the word static is simply because we have to have this as a script that everything can keep track of. So if we update this once without the word static, it won't be updated in other versions of the script, i.e. other scripts attached on other objects. Now, we are going to do this two different ways in this tutorial, so don't worry if you're not happy with this way, we will do a different way as well, and then you can choose which one you want to stick with. So public static, and this is also going to be an integer, and we'll call this coin count, semicolon. Now, once we have our tag here and we have set the game object as false, before we do that, we need to have the text updated with our correct score. So to do that, we would go text score dot get component. So what we're basically saying here is we are referencing the component which is inside our text box, and that's going to be text open close bracket dot text, and that is a lowercase t there, and we are making that equal to, and in quotes we'll have the word score just like we typed before, space, then another quote, and then plus that variable coin count, semicolon, and save the script. So all we've done here is we have said that we are going to make this equal to that, but there is one vital thing we haven't done here. Have you noticed it? Of course, we haven't actually specified any value for coin count. That's where we also need to add an extra line to add 1 to coin count every time. So coin count plus equals 1, semicolon, and save. Obviously this can be any number you want. It could be 100 per coin, it could be 1,000 per coin. It's entirely up to you. But all we've really done is just say this is our text object, this is our coin count, here is where to find where to update the text. I'll show you this little section in a minute, and this is what we update it with. So if we head back into Unity and let it compile, and if we click text now, you can see that that is the text component and that is the text subcomponent that we have just updated, also called text. That's why that works. So next, we'll use that little trick from last time. If we select all of our coins, you'll notice that that text score now appears there. So let's drag and drop text onto there. And now let's press play. And we should see the score update as we collect coins. There's 1, 2, 3, 4, and 5. So I did say I was going to show you another way. You can stick with that way if you want to. This one involves creating what is known as a global script. So let's right click, create C# script, global coins. Now, I do prefer to use global scripts for many different reasons. The main reason being it gives us a bit of a chance to keep everything in order, but I know some people do prefer to create this type of script. Now, all we need to do to make this work is we can still take this using Unity engine.ui and place it in global coins in the same namespace. And we need to take both of these variables. So if we take those two variables and place it here in global coins, and I think I'm going to get rid of the annotations and void start for now because we do not need them, but we do need the update method. Next, what we need to do is we need to take this line of code, the text score.get component. Let's take that line out and let's place it in global coins. And finally, we can actually get rid of everything we've copied over in that coin collect script because we don't actually need it there anymore. However, this coin count plus equals 1, sorry, not -1, will still be required with just a little bit of modification. So what's going to happen here is this script is going to talk to global coins. So what we'll do is we'll change this coin count plus equals 1, and we'll change it to be global coins.coin count plus equals 1. So what that's doing there is it is adding 1 to the variable in global coins. So this now works the exact same way. So save all them scripts, head back into Unity. And these coins still have the script on, but they don't have that extra variable. However, what we need to do now is game object, create empty. And that empty game object we can now attach global coins to. And then we can attach that text box over here and press play. And all of this will work the exact same way as before. There we go. It's just a different setup altogether, and everyone prefers something different, so you can go with whatever method you would like. I figured I would teach both just in case, but I'm going to go with that second method that we've created. So first thing to note is you'll notice I have a window open here in Chrome, and it is known as the Asset Store. So there are a couple of different ways to access the Asset Store depending on what version of Unity you are using. If you are using Unity 2020 and above, at least for now, you cannot access the Asset Store via the Unity editor itself. You have to do it via the website. Why Unity has made that decision, I'm not entirely sure, but I do consider it a bit counterproductive. Either way, because I'm using version 2020 in this tutorial, we will be using the website. I will show you a little later on how you can actually still do all the exact same thing via the Unity editor itself. Either way, if you want to do it this way, you can. You just go to assetstore.unity.com. Now we're going to search for a character that we'll be able to use in our game for free. So if we go to search, and we can search here for pretty much anything at all, absolutely anything. And what I want to go for is, you've probably seen it in the thumbnail, is that little low poly animal. So if we go to search and type, let's say free low poly animal. Free low poly animal. And you should see it probably first, second, third, right there. You don't have to use the same one as me. You can use a completely different one. I guess it just depends on your preferences. So I've gone with this one, and I have already downloaded it earlier this year because I've used it in a couple of different projects, as you can see. And all we need to do is open in Unity. So we literally click that button, as long as you're logged in, that is, so make sure you are logged in. And it will take you over to the package manager. And again, I feel this is a bit counterproductive from the original Asset Store, but it is what it is, unfortunately. Either way, when you get to this screen, you should see it selected here, the asset you've just brought into Unity. You just then need to click download or import, depending on whether you've previously downloaded it or not, or whether you previously imported it or not. Either way, as long as you've downloaded it and imported it, you shouldn't have a problem. So when you do import, you'll be presented with this screen. We just need to import. It'll take just a couple of moments to bring it over into Unity, but you shouldn't have much of a problem after that. There we go. And now we can see this folder has appeared down here. So let's click back to the scene view off the package manager. And next what I want to do is bring in some sound effects and some music for our game. So while we're here, let's right click, create, folder. We'll call this one audio. And within this audio folder, we're going to have another folder just for effects. So right click, create, folder, FX. Now what we'll do is we will bring two audio clips over, so we can drag and drop these into Unity. And if you want these two files, you can get them on my website. Link is in the description. Head to the downloads and assets section and go to the correct tutorial section, and you can download these under lesson number 8. So drag these into Unity. Make sure you do unzip them from the file if you get them from my website. And then let's drag this coin SFX file into this effects folder. Now we have everything set up nicely. There's our audio, there's our game background music, and if we go further down, we can see our effects right there. So let's do this in this specific order. Let's add some game music. Let's add a sound effect for collecting the coin, and then let's add the player character at the end. So how do we make it so as we can have this music playing while we're in our scene? It's very easy. So we already have an empty game object here. Let's use this empty game object that we attach the text global coin script to, and use this as kind of like a global mechanic. So we've got all kinds of different things on here. So we could theoretically attach our game background music to this game object. I'm going to set its position to 0, 0, 0, so it is in the center of our scene. Now you can drag and drop that game background music over here, and it will add it as a component. So I'm not going to go into much of this here, but the main things you want to note here are play on awake is ticked, so as it plays straight away. Loop is ticked, so it constantly loops, and probably things like pitch and volume. I'm going to reduce the volume because I do believe the audio for this is fairly loud when I made it. So I'm going to reduce it and keep the pitch as 1. You can mess around with the blend if you want to, but honestly, I think it would probably serve its purpose well enough as it is. So if we press play now, we should hear it. And that is quite loud. That is quite loud. So obviously we do need to reduce that a little more. So I'm going to have 0.05. I don't want it too loud, but I don't want it too quiet. And I think that will probably do just about right. So next thing we need to do is we need to add some sound effects for when we collect the coins. And I'm going to do this on the main camera. So I'm going to right click, create empty. We'll have this as FX. And in here, I'm going to right click, create another empty object, and I'm going to call this one coin collect. This time, let's go to our effects folder and drag and drop coin SFX onto the object up here. Like so. Now what we need to do is untick play on awake. The reason we do that is because we only want to be able to play this audio clip via script. We don't want it to play straight away. So how do we make it so as we can play that audio script from collecting a coin? It's pretty simple. Let's go to our scripts folder and let's go to our coin collect script. With this, we now need to add an extra variable. So let's add public. Now the type of this variable is going to be audio source with a capital A and a capital S. Audio source, and we can call this anything we want. Let's call it something relative to what we're doing. Collect FX semicolon, and then before we have counted an extra coin there, so before global coins.coin count plus equals 1, we now need to put collect FX dot play, open close bracket, semicolon, and save our script. Now, if we head back into Unity and just let that script compile, we can then select all of our coins like we've done a couple of times before, and you'll notice that that collect effect is there. So all we need to do is drag and drop coin collect onto there. And now we've assigned that sound into the variable. So if we press play, we should be able to hear the collect sound. Perfect. So now we're starting to get into something which we would consider a game. It's starting to look a bit more presentable. So what we'll do now is we will add one of these models that we imported at the beginning of this tutorial into our game. So let's double click on player, and we can see here it's still just the cube. However, we are going to continue using that cube as the player, but we're going to do something very clever. We're going to attach a game object inside that cube, which will look like it's an actual player rather than the cube. So if we go to this gloomy animal folder And if we go to meshes, we can see we can use a chicken, a condor, or a dragon. All three of those are in the thumbnail. I guess it's up to you which one you want to use. There's no right or wrong here. Again, you can use a different model completely. But should we take this dragon? Let's take the dragon. And what we'll do is I will drag him onto player. And we can see there he is. So I think he probably does need to be reduced in size a little bit. He is quite large. So let's reduce the scale to 0.5, 0.5, 0.5. Is he a little too small now? I think he might be. So let's increase the scale. 0.75, 0.75, 0.75. And I think that probably looks not too bad. Again, I think it's more a case of you kind of refining this a little more. If you want to have it as 0.5, you absolutely can. It's your game at the end of the day. So I'm going to keep him as 0.5. And what we'll do now is we will take the player and then untick Mesh Renderer. Now let's press play. It's not going to work exactly as we want. However, we now have a player rather than a cube, which still works. So the idea of what we've done here is that we are keeping that cube as the actual player. However, we now have a model inside the cube and we have turned the rendering of the cube off. So it visually looks like the model inside the cube is what is being played here. So animation can be done through Unity, or it can be done through whatever application a model is built in. We're not going to do an animation in Unity because we already have an animation that comes with this model that we attached to our game last time. So if we go to that animations folder, we can see a couple of different things, and the one we're dealing with is Dragon. Firstly, we have the controller, and in its simplest terms, you can think of the controller as something which attaches to the animator component, which allows you to control animations, i.e. what animations are there. The next object along is an FBX, and this basically contains a couple of extra files all in one, and if we click the little play button next to it, we can expand that out. The file we need to use is this one here that says move. This is an animation file. If you're in an older version of Unity, your file may look a little different, as you've probably noticed by now, but realistically it's going to be the same kind of thing. I think the older versions before 2019 have a little play button. So we need to take this animation, hold Control and press D, and it will duplicate it outside of that FBX, so it becomes its own individual object. Make sure loop time is ticked up above. And now what we need to do is just drag and drop this animation onto our character, which is the dragon. Make sure we don't drag it onto the player because this is the cube. There's no animation on there. It's all on the dragon. So drag and drop. And you'll notice that the controller now becomes Dragon 1 because we've created an extra controller. And that means the animation is on there. To double check this, we can double click the controller here and it will open up the animator panel. And we can see here that move is indeed attached to the entry point. So we could attach further animations here if we wanted to. However, we don't really need to at the moment. We just want our character to move. So let's click back to the scene view and let's press the play button and we should see the animation. Cool. So now what we need to do, we have the animation in place. We now need to set this up so as our character faces the correct direction. Now we're going to do this in a very clever way because we're not actually going to rotate the player cube. We're only going to rotate the model. It's not really going to matter at all in its simplest terms, simply because the model is all we're ever going to see. So as long as the model's fine, there's no worries at all because there's no reason to rotate the cube whatsoever. So let's go into our script where we can modify this. So let's go to our scripts and we're going to need the player control script. So let's head back into there. So we are going to basically create a couple more if statements to detect what keys we are pressing a little later on in this tutorial. But for now, all we need is an extra variable, which is going to be the dragon itself. So let's declare this here. public game object, and we can call this anything we want, but let's make it relative to what we're doing. So we'll call it player dragon and a semicolon. So the easiest way of doing this is whenever we're pressing a button, we make our character face that direction. And the way we do it is based on rotation. So we have to rotate our dragon locally. And what that means is that we only rotate what's inside the cube, i.e. the dragon. So we'll start with the very first if statement, key code A. So we need it to face in the left direction, which is going to be 270 degrees. If you imagine up at the top is 0, to the right is 90, down below is 180, and to the left is 270. So we go in increments of 90 right angles. So let's try this. What we need to do is if we go below the movement here, and we now need to say player dragon, because we're referencing just that dragon, dot transform dot local rotation, and you'll notice it's a lowercase l and an uppercase r there. So make sure you do get your capitalization correct. Equals, and now we have to define what we're doing here to the rotation. We have to use the term quaternion, which if you start typing will indeed show up by default. Dot Euler or Euler angles. It depends on your pronunciation here, but it's spelled E-U-L-E-R. And the way this works is it's now telling it to basically rotate on either X, Y, or Z, or all of them, depending on what we put here. So in brackets, we now need to put 0 for the X, 270 for the Y, and then 0 for the Z or Z, semicolon. So what we've done here is if we're pressing A, it means that we are now going to rotate the player to the left, i.e. 270 degrees. So we can copy this line of code and we can place it here. And now this is going to be 90. So 90 degrees would be to the right. Remember, 0 is at the top, then 90, then 180, then 270, which means that key code W, which is up, is going to be 0. So we're completely resetting the rotation there. And finally, S is going to be the inverse of 0, which will be 180. So let's save that script. Head back into Unity, let it compile. And let's press play and make sure that it does indeed work. Oh, of course. This is a classic Jimmy moment if you haven't, this is your first time with me. So on the player itself, we do have to actually define the player dragon right there. Sometimes I have to wonder about myself, but this is actually a great way of seeing something here. This is an unintended bit of education now for you guys. So you'll notice down the bottom, we have a red warning saying unassigned reference exception. If we now click on console, this will tell us where we've gone wrong. We can see right here, you probably need to assign the player dragon variable of the player control script in the inspector. So right there, if you come across that kind of error, you've done the exact same as me. I could get away with that and say that that was intentional, but I think you guys probably know me best now. That was not intentional, that was a Jimmy. I did a Jimmy. So let's clear that. Let's go back to project, let's press play, and now let's see this in all its glory. There we go. Excellent. So there is one extra little thing that won't work here. Are we ready? There we go. That just looks utterly crazy. He's not facing the correct direction. So the direction he's facing can only be up, down, left, or right. There is no middle direction. So if we held W and D, for example, he wouldn't go up to the northeast. So we have to write some extra lines of code to compensate for that. So if we go back to our player control script, we now need to write a couple of extra if statements below here. And these if statements are going to be able to detect if we're pressing two keys at once, i.e. if we press W and D, then our actual rotation needs to be 45 degrees rather than 0 or 90. So to do that, we use the exact same kind of code. So let's go if input dot get key, as we've done previously, and in brackets key code dot w, and instead of carrying this on, what we do is we do double ampersand, because that is an and. So we need two if statements to exist at the same time. So if we repeat what we've done here, but with the D key, so input dot get key, and in brackets key code dot D, and then open curly bracket, you'll see what we've done is we've said if we're pressing W key and the D key, then we need to do whatever we need it to do. So in this case, we'll copy this line of code here, place it in this if statement, and we'll say that this is now 45 degrees. So that means that our player is going to go 45 degrees only when we're pressing W and D. Now obviously that same principle is going to need to be applied for when we press D and S, when we press S and A, and also when we press A and W. So let's copy that, place it below, and change this to key code D and key code S, and that is going to be an additional 90 degrees on top of 45, so that's going to be 135. Once again, we need to do the same, so in this case it's going to be S and A. So if we hold S and A, we want to move southwest, which means that this is now going to be 225 because we're adding 90 degrees to our 135. And finally, the last key code combination is going to be A and W, which means that this is now going to be 315 because we're adding that extra 90 degrees to 225. And that's all there is to it. This whole script will now make our character move in the correct direction and face the correct direction at all times. So let's save our script. Let's head back into Unity. And there we go, it has indeed compiled. And let's press play and make sure this all works. So down and at angles, there we go. You can see our angles all working. There we go. Every single one works just fine. Cool. So feel free to modify that as much as you need to. If you need it a bit more refined, you absolutely can do that. So physics in general is something which you see, I would say, in probably 99% of games one way or another. And physics aren't just necessarily gravity. They could mean anything at all, whether you're moving an object, whether you're letting an object fall, whether you're doing anything. And usually when it comes to Unity, anything which involves physics will have something called a rigid body attached to it. Now, we're going to do a couple of things in this tutorial just to kind of illustrate how this all works. So if we take our player, for example, and if we add a rigid body to our player, we're going to get an effect which may not necessarily be what we want to achieve here. However, we will have some objects in this scene a little later on which do have rigid bodies, which we'll be able to move, and we will get the desired effect from. So let's go to Add Component, and then let's go down here to Physics. Make sure we are on our player. And then let's go to a rigid body right there, and let's click it. And you'll see that new component gets added right at the bottom there. So if we take a look at some of these options here, most of the time you won't need to worry about it too much. By default, a lot of things in Unity do actually come well equipped. Only difference you might have at the moment is if you're brand new to all of this, you may have constraints like that. So if you tick, or rather click, I should say, the little arrow next to constraints to bring this down, we'll play around with some of these in a moment. But if we press play now, we should be able to see how our character or player reacts with some physics. Not quite so well. You can see we did not achieve the desired effect there, but you can now see that he is having issues with gravity. So let's untick that. So if we tick all of these now, the freeze position and freeze rotation on the X, Y and Z, then we're not going to have any difference at all, basically because we have effectively disabled any possible gravity or anything to do with physics. And obviously we can work around these a little bit more. So what I want to do now is add in a cube and attach a rigid body to that and see what effect we can come up with. And you'll see that we're able to actually move it. So let's go to Game Object, 3D Object, Cube, and let's zero out that position and bring it upwards. And let's just move it over here for now. And as I said, let's add a rigid body to it. So let's click Add Component, Physics, and Rigid Body. Let's not change any of the constraints. Let's leave the mass, drag, everything as it is, because we want to use gravity, so make sure that is ticked. And now, if we head over, there we go. We can achieve that effect if we want to. Now, you have to remember that there are many, many ways to deal with physics in Unity. And that is just one of the ways we could perhaps move a block. And that is all dependent on how our player is set up. So if we go back to our player and let's actually remove the rigid body completely, we will now have a different effect on this cube. Let's head towards it. And you can see we just push it rather than blast it away. And off it goes. And obviously at the moment our character is not affected by any kind of gravity, so he wouldn't fall even when he goes off this area here. So let me undo that now, and we'll attach the rigid body back to the player. And now let's duplicate this cube a couple of times, and let's see what effect we can come up with when moving these objects. So I've duplicated it, so we have 8 cubes now all in one place. Let's press play. And let's see what effect we get when we hit this cube now. Cool. So I think depending on what you want to do with your objects, you know, how you want to move them. Do you want it to be blasted like that? Do you want it to just be moved? It's all dependent on how your character reacts. So if we do the inverse of that, so I'm going to select all of those cubes and I'm going to freeze everything on the cubes. And if I go back to the player and unfreeze, in fact, no, we'll remove the rigid body once again and let's press play. So once again, we're going to have a little bit of an issue there, simply because the way we have set this physics up. So it's important to realize that everything you do when it comes to something like a rigid body is going to have a massive impact on what you're doing here. So once again, let's undo that. Let's have everything ticked on our player. And let's untick everything on the cubes. And now let's increase the mass to 10 on those cubes. And remember when we just went into them and they kind of just blasted off a little bit? Well, now, not quite so much. So you can see how playing around with this rigid body is having a positive or negative impact on what you're doing here. So basically, if we put the mass as 1,000 and try going into our cubes, they are dragging even more. So we're ending up with that original effect that we had. So it might be wise playing around with the mass as well, because in the long term, you can actually create 2 different effects just by changing that mass. So to put that into practice, what I'm going to do is I'm going to set the mass back to 1. Let's move some of these cubes around a little bit. So let's bring this one here. Let's bring this one next to it. So let's set the mass of this one to 1,000. And obviously the mass of this one will be set as 1. So these will move depending on how the mass is set up here. So we can go knock it, or we can push it. So like I say, what it comes down to is how you want it to be set up. One of these two methods is kind of cool. A combination of both of those methods is cool as well. So I do like the idea of, let's say, trying to get through some of these cubes. So let's actually set up a cool little effect here. Let's set it so as this cube, which goes flying off, knocks a couple of other cubes, like so. And let's bring this one up, and bring that across, and bring that across. And I'm going to get rid of that cube, and let's get rid of some of these other ones. And I'm going to have this one over here. And I'm going to increase the size of this one. Let's have it 2 tall. So we can move it a bit like a column. And let's see what effect we can come up with now. Cool. So I'm going to keep these movable objects as they are. What I might do is I might quickly rename them. In fact, do you know what? Let's add a material to them as well, because why not? I think we need some material. I'm thinking like a nice dark grey kind of colour might do the trick. So I've got them all into place. So let's go to our materials. Let's right click, create, not C#, material. I don't know why I said C# then. I think it's a bit of a habit. So let's have this as dark grey material. And I'm thinking I want it slightly different than how the red is set up. I want these to be very, not generic looking, but just a bit more plain. So let's have dark grey about there. And I'm going to attach it to the main column. Let's duplicate that red material now, and let's change that to a light grey. So something like that. And let's rename it to light grey material. And let's attach it to each one of those. And let's see how that looks. Cool. Awesome. So physics is always a lot of fun when it comes to Unity, because you can try doing one thing but then end up creating something completely crazy, which might end up being either hilarious or might actually be something useful that you could actually put into the game. So I'm going to now rename these cubes just so as they are not called cube. I'm going to rename them to something more useful while I tell you what we're going to do in the next tutorial. So next tutorial, what I want to do is add in a timer. Now the reason I want to add in a timer is because we want to have some kind of challenge to all of this. And I think, let's say, a 30-second timer would be kind of cool. So basically, if we can't do the level in 30 seconds, then we fail the level and we have to restart. So a countdown timer is going to give us a bit of a challenge to this game now. So it's all good and well having a game where we can wander around, be able to pick up some coins, but there's no point to it yet. A timer then gives us a limit, something to try and achieve before something else occurs. So let's start by creating some simple UI for our timer. Let's go to our canvas and let's go to our text. Remember, this text was for our score, and we can use the similar mechanic that we created here to create that timer. So I want our time to be over on this side of the screen. Let's take all 3 of those, hold Control, press D to duplicate, and let's bring it over here. Now, we've created a separate version of that score. And essentially, all we need to do is just change this to say time, and then we'll have 30. So much in the same way as us updating our score every time we collect one of the coins, what we're going to do here is have a script that updates this time figure constantly. So every second it will reduce. So in order to achieve that, we're going to need to create another script. So let's have right click, create C# script. We'll call this global time. And let's open that up in Visual Studio. So as I said, the way this is going to work is every second we will have a variable which will start at 30, and then after a second it will reduce it to 29, then after another second reduce it to 28. And we will do this until that time reaches 0. Then obviously we have other things to do once it reaches 0, because it'll just end up counting down constantly. So we need to kind of work to avoid any negative time. So once this is loaded, we are going to start by creating a coroutine as well as a couple of variables. So it's just loading up now. Sometimes Visual Studio can take a little bit longer than it should to open up. And there we go. So for some reason it has decided it wants to open up player controls. Even though we don't need player controls, we need global time. So just make sure you do have global time open. So as I say, we're going to start by creating that coroutine. So let's have enumerator, and we'll call this deduct second, open close bracket, parentheses, and open the curly bracket. So because we're doing this in a second, we now need to wait for 1 whole second before we execute any code, i.e. take off 1 from our second count. So yield return new, wait 4 seconds, and in brackets 1, close bracket, semicolon. So what I'm going to explain here is let's go through some of the scripts we've already written so far. So global coins, coin collect, camera follow, player controls, and if we scroll down, player controls, and then coin rotation. So for those of you who are indeed brand new to Unity, I've done something now which may have confused you, and this is obviously quite intentional. I have done this down here, and I mentioned that as a coroutine. Now, so far we haven't even dealt with coroutines, and you may be wondering, well, why can we not put yield return new, wait for seconds in void start or void update? So the reason being is a coroutine and a method are two different things. Obviously, these are methods, and this is now a coroutine. A coroutine allows us to control time in its simplest form. And because we are creating a script which has to control time one way or another, we have to use this. Now, I hope you're not too confused. And like I said, the intention there was to kind of make you jump straight into the deep end of a coroutine without explaining anything and then seeing how you feel about that. Obviously, coding is very difficult. So if you've got to this point in the video and you're still feeling comfortable, then don't worry, you're not going to have any more problems learning how the coroutine is working. So all we're going to do here, to kind of take a step back, is the coroutine is going to deduct a second from our variable every single second. But we cannot just invoke a coroutine when the script loads. We have to tell the script it's got to do that coroutine. So that effectively means that in void start, when the script starts, we have to start the coroutine. So let's do that. Start coroutine, and in parentheses, the name of that coroutine we've just created. So in this case, deduct second, open close bracket, and semicolon. So what's happened here is as soon as the script starts, obviously this start method runs, and then it will immediately start this coroutine. And this coroutine is something that we can constantly kind of use, if you understand what I mean. It's something that we can invoke instantly, obviously when we've started it up here. So it will instantly wait for a second before we do anything else. So because we're going to be dealing with UI again, we need to add in the namespace at the top using Unity engine.ui. And obviously we're going to need some of those variables. So let's add a couple in. We may need to add in a couple more depending on how we work with all of this. But essentially, the two we're going to need first and foremost is the UI text on our screen, as well as a count for the seconds. So public game object time, if I can type properly, display, and public int, again short for integer, and seconds, semicolon. So what we've done here is say that we have two variables. One of them is the UI, the other is the seconds itself. So that now means that after a second, we are going to reduce seconds by 1. So we type seconds minus equals 1, semicolon. But that does also mean that we need to set a standard default for our seconds. And like I say, I think 30 is a good number for us to work with. Obviously, if you want to make yours more challenging, you would change it here. You can also change it in the scene itself because it is a public variable. But for now, that's completely fine. So the clever thing, what we're going to do is we can either use a loop if we want to, or we can do this via update using a bool. I always say that there are many, many ways to achieve the desired effect in Unity. And it's up to you whichever way you want to do it. You could use a loop, you could use it using a bool. I'm going to use a bool in this tutorial because I'm also going to use that to my advantage for when we get game over later on in this series. So let's add a bool in there. So public bool. Let's have this as deducting time. Obviously, by default, that will be false, so we don't need to place false here. So we now need to make sure that through all of this, we make sure that everything here functions as normal. And I guess the way we have this set up as starting coroutine as soon as the script starts may not necessarily work in our favor because we're using a bool. If we're using a loop, then probably it would work. However, we're going to do some clever modification so we don't need to have start coroutine inside the start method. In fact, we won't even need that start method at all. So let's carry on with our coroutine, and we're going to say time display dot get component, and in spiky brackets text, so much in the same way as we did with the score, parentheses open close dot text equals, and now we need our text to say score, and then colon, space, and then the quote again, and then plus whatever our time is. So in this case, we just put seconds with a semicolon. So essentially what's happening here is when our score, or rather when our game starts, our score will be 30 because that's what we've put as default. Our coroutine will start, and after a second, it will reduce 1 from that seconds and then update that UI right here. So after that, what we'll do is we will say deducting time equals false. And you're thinking, well, we've already set it as false. Why is this the case here? Well, like I say, we're going to use a clever little bit of coding so we're able to update this constantly. So we're able to, rather than have a loop inside the coroutine, we're going to be able to invoke that coroutine so we're able to stop it whenever we actually need to, i.e. when we hit 0. So this is a good chance for us to really go into if statements again. So we're saying if, and in brackets, deducting time equals false, then open curly bracket, and we'll say deducting time equals true because we are now deducting time. And then at the same time, we can copy this line of code here that says start coroutine deduct second and place it below. We can now get rid of that start method completely. Save the script. So just to kind of go through what's happening here, because I feel sometimes with a coroutine it can be a bit confusing. So we are starting, void update is always running. So we are starting the update. We're checking if deducting time is false, which it will be when it first runs, at which point it then sets it true. That means that this if statement can no longer run, but we have started this coroutine. That coroutine starts by waiting a second. It then reduces a second and then updates the display, and then deducting time turns to false, which means we end up back here. So we're looping this constantly. Now, at the moment, this will go to -1. However, we will be able to sort that in the next tutorial when we end up with game over. So let's have this all set up now so as our time actually runs correctly on screen. So let's head back into Unity. Give it a moment just to update. Now, I am going to rename this game object that we had previously. This game object is going to be our global object because we already have the global coins on there. So I'm just going to have that as globals. And obviously I'm going to keep the game audio on there because that is also a global object as such. So we now need to drag and drop global time over here. So it's now right there. You can see there's our second set. Our deducting time bool is ready. So our time display is going to be this. But I think this is probably also a good time to rename these texts here. So time display, we'll have that as coin display. We should probably have this as coin border, and we'll have this as coin back, and then probably do the same for that. Time border and time back. So now everything is named as it should be. So let's head back to that globals object, and we just need to drag and drop the time display onto there. I'm going to save my scene, press play, and we should see our time countdown. Just realised I have made a silly mistake. I don't know why I put score there. I'm hoping some of you guys commented as soon as I did that. I really hope you did. Please, I really hope you did. So anyway, it says time rather than score. There we go. And I think I'm going to bring these over just a little more to there. And do you know what? Now I think about it, I think I'm also going to change the size of these as well. So I'm going to take the rect tool and just reduce them to about there. And let's press play. There we go. Awesome. So we're counting down now. So let's see what happens when we get to 0. Let's collect these coins here while we can. So you can see that the score is still updating independently. The time is updating as standard. So obviously it will hit 0 now and it will carry on. So either way, we now have our time mechanic in place. What I would recommend you do before the next tutorial is probably tidy up your UI a little bit, get it looking how you want it to look. So up until now, our timer counts down every single second, but when it hits 0, it still keeps on counting. Now we can use the script we've already written to our advantage to allow ourselves to respawn in the level. So what we're going to do is we're going to create a cool little scene that we can use to manipulate levels. And what I mean by that is we can use the same scene to take ourselves to different levels whenever we've created them. So we could use this as, think of it as a respawn scene. So that's probably what we're going to call it. So let's go to File and click New Scene. And then let's click File again. And let's go to Save As. And let's go to our scenes. And we'll call this Respawn. Now all this scene is going to be is just an empty scene with perhaps a black background. And it's going to have a little script in it which will allow us to go back to the level that we're supposed to be in. So we're going to be using something called scene management with this tutorial as well. So we'll do quite a lot here. I just hope it doesn't drag on for too long. So let's go to game object and let's go to UI and let's go to raw image. Now I know we've not dealt too much with how UI works, but essentially all we need to do here is just create a completely black background. So let's have this stretched. Let's have it 0, 0, 0, 0. So it stretches all the way across. And let's change the color to black. And if it goes to game view, that is how the scene will look whenever we start it. And like I say, we can use that to our advantage. Next, what we need to do is create a script which will allow us to basically load up our other level. And to do all of this, we are going to have to manipulate how our scenes work. So while we're here, let's save our scene. Let's go to File and let's go to Build Settings. Now let's click Add Open Scenes, and you'll see that this appears at the top with a value of 0. While we're here, let's add our other scene, which is currently called Sample Scene. You can change the name of it if you want to, and that will give it a value of 1. We can swap these around if we want to, just by dragging and dropping. So now Respawn Scene is currently value 1, Scene 1, and Sample Scene, our original scene, is value 0, which is Scene 0. This one will always be the first scene to load. So, how do we make it so as this scene instantly takes us to our game? Let's go to Scripts, let's right click, Create, let's go to C# Script, and we'll call this Respawning. And let's open that up in Visual Studio. And basically this script is going to have the ability to, as soon as it loads, just instantly take us to another scene. So we're going to need to use a namespace here. We need to have using Unity engine dot scene management with a semicolon. We don't need the update method, and we do not need the annotations. They can disappear. And the only line of code we'll need here is scene manager dot load scene, and in brackets 0, because currently our main scene is scene 0. This will change later on in development. We're going to make it a little more dynamic, and ultimately for now we just need it to take us to the scene, so we don't need to worry about that 0 being anything else right now. So let's have a semicolon there and save. Now let's head back into Unity. And there's nothing special we have to do really. All we need to do is just make sure this script is in this scene, so we can attach it to pretty much anything here. I'm just going to attach it to the camera. And there we go. You can see the script is down there. So let's save our scene. And what will happen when we press play is it will basically load up our other scene. Perfect. So just to show you how that actually really works is if we disable that script and press play, we will indeed stay in the scene. And as soon as the script becomes active, we end up in another scene. So like I said, I've said it a few times this lesson, we can use that to our advantage. Just by loading this scene, we instantly reload our other scene. So let's head back to our main scene. Make sure we save that one. So when we want to respawn when our timer hits 0, we can use the same mechanic there and load that other scene, which will instantly reload this scene, and everything will be reset. So we've respawned the entire level. So let's head to our scripts. Let's go to our timer, which is global time. And let's add at the top the namespace using Unity engine dot scene management semicolon. Now what we have to do here is we have to establish the moment when our timer hits 0. Do we make it so as soon as it hits 0 we respawn, or as soon as it's supposed to hit -1 it respawns? I'm thinking we should make it as soon as it hits -1. The reason for this is because it will basically look like it is only giving us until 1 second before we respawn. So keep in mind that we want anything to trigger as soon as it gets below 0. So we can do this in void update. Let's do it at the top. And we can say if, and here we need to put the seconds equals -1, then do the following. And what we're going to do is we're going to permanently make the value of seconds, at least in this script for all intents and purposes, keep it as 0. So we're going to say seconds equals 0. And we're going to have scene manager dot load scene 1 semicolon. And ultimately, what's happening here is we are going to that other scene and coming back again. Now, we do in fact need an extra layer of protection here, simply because we could effectively still change it with this. So we're going to have an else statement here. And we're going to open the curly bracket there and close the curly bracket after our original if statement. So the reason we've had to do this is because if seconds isn't -1, then we go down here and run this section. If it is, we only run this section. Therefore, we cannot mess with the time any further and we reset. So this will be advantageous to us whenever we add a little bit of extra UI to our game. For example, we perhaps say ran out of time and it fades out and then respawns. So as long as we get the main respawning mechanic working here, we don't have a problem at all. So this is going to be our game over and respawn. So let's save that script. Let's head back into Unity. Let it compile. And let's press play. So I'm not really going to do much here because there's no point. We just need the time to run out. Let's bash these blocks around a little bit. Okay, so our time is coming to an end now, and we should be getting game over and respawning in a couple of seconds. Now it did flag to -1 there, I think. So there's a couple of things that we need to sort out now. Let me see. Let's go back into global time. And I'll tell you what we'll do. Let's actually change this to 0 and see if that does indeed make a difference. I may have overcompensated when I set it to -1 because of our wait time here. So if you get that problem, you may need to change it to 0. I think it all depends on where we have our waiting period down here in deduct second. So while we're at it, let's change that. And I think we do need to go back to our respawn scene, simply because I think I turned this off, didn't I? That's why we didn't respawn. So make sure that is indeed ticked. So let's go to our main scene and try once again. So hopefully you guys can see how all of this is piecing together now. And what I would like to do next tutorial is I want to... It's a bit loud, this music, isn't it? I want to make some animation to this so we kind of fade out to all of this and then perhaps maybe fade in. Not quite sure, but I want a game over on the screen as well. Some text to say that we've run out of time. So let's see if this works now. Okay. That should probably do the trick. We did indeed see 0. It didn't reset on 1 second. So everything works as intended. So yeah, next tutorial we're going to add some more UI to kind of expand on that and say you ran out of time and maybe a fade out as well. So let's deal with some UI elements so as we don't just instantly respawn. So it kind of fades out and tells us, you know, we ran out of time. So let's start with the UI text. So it's all going to be done inside the canvas. So let's go to Game Object, UI, let's go to Text. We'll set this text in the center of the screen. So we'll zero out the position so it's dead center. And I'll put this as you ran out of time. Just as simple as that. And let's have this as size 40 maybe. Let's have it center. And let's change the color to white. And let's use the rect tool to adjust the size of our box. You ran out of time. Let's have it dead center. So this should flag up like that on our screen whenever our timer hits 0. So, in fact, I'm going to have that as bold maybe, and maybe a little bit bigger. There we go. So now let's also deal with a fade screen. So there's two types of fade screens. There's a fading in and there's a fading out. Fading out means you're fading out of the scene to black, and fading in means you're fading in from black to the scene. We're going to create the fade out effect in this lesson. So let's go to Game Object, let's go to UI, and let's go to Raw Image, much in the same way that we did in the last tutorial when we created the completely black screen. And we're going to do the exact same here. So we need to anchor and stretch, set everything to 0, and then set the color as completely black. And we also need to set this alpha as 0. The reason we set the alpha as 0 is because we want it to be completely transparent. We need it to go from complete transparency to complete translucency to complete opaqueness, if opaqueness is indeed a word. Anyway, what we need to do now is create another folder, and this will be specifically for animations. So we're going to use an animation to control that fade out. So let's right click, create, folder, call it animations. If I change my caps lock, of course. There we go. And go into the folder and then make sure we are on that raw image, and let's rename it to fade out. And let's have the text renamed to, in fact, we'll have this as time up text. And I want that to be on top of the fade out, so round about there. So the order of this canvas does indeed affect how this is displayed. So this will always be on the front, and then everything going up will be heading backwards. So what we need to do now is add our animation tab, and we need to create a quick animation for fade out. So to do that, if we go down here to our project window, click these little dots here, and then go down to add tab, and then click on animation. And it'll add this tab right here. Now it's very simple to use, at least for simple animations, what we're trying to do here. So don't worry about being too worried about everything going on. So all we need to do is click on create, and we'll call this fade out, in the same way that our actual asset is called fade out. Now what we need to do is click on the little record button, and what this will do is it will start the actual animation recording. And we don't have to actually physically do this. We can actually set this by determining different things down here. So frame 0 is the very first keyframe, and a keyframe is dictated by a certain position of the animation, and in this case what we need the keyframe to be is the exact starting point of our raw image, which is exactly as we have it set up now. So what we need to do to actually put that in there is make a quick change and then revert it. So if we click anywhere in the alpha, you'll see these two dots appear here, and then set the alpha back to 0. That's now set the very first keyframe, so the animation will start exactly as this is set up now. Let's say we want to fade out over the course of 2 seconds. We're working in 60 frames a second here, always in 60 frames a second. So what we need to do is put this as 1, 2, 0, as that is 60 times 2, which is 2 seconds. And after the 120th frame, we want our alpha to be completely black. We want it to look like that. So let's indeed do that. So now we can press the record button once again, and that is our animation. And if we press play, we'll see this loop over and over and over and over now. And obviously we only want this to play just the once. We don't need it to necessarily keep playing. So what we need to do is in the animations folder, click on fade out, and over here you'll see loop time is ticked. We need to untick loop time. That means it will only play once. Perfect. So now let's combine all of these together to create at least a half decent respawning look for our game. So we can use many different methods of controlling animation here, but honestly, with a fade out, the easiest thing to do is just to turn the object on rather than play around with any animation code. You're also saving maybe a couple of bytes with the code just by turning something on rather than saying play an animation. So let's untick fade out up here so we turn it off, and let's also untick time up text. So now our game looks exactly as it did before. Perfect. So we now need to modify our time script. So let's head to scripts, let's head into global time. And if you remember, what happens here is as soon as it hits 0, it just respawns. So we're going to create a separate coroutine to allow us to control before we actually respawn. So let's add two variables, which is going to be the text we've just created and the fade out. So public game object time or text, and then once again public game object fade out semicolon. So what we can do here is as soon as we hit 0, we can turn those two game objects on. So time up text dot set active true semicolon, and then it is fade out dot set active true semicolon. Now we don't want this to play here because these won't even appear, because in the same frame it means that we're just going to instantly go to another scene. So we need to get rid of that line of code and place it inside a separate coroutine. Thank you, Avast. Tell me my PC's being slowed. So let's have enumerator, and we'll call this respawning level, open close bracket, open curly bracket. Now the first thing we need to do is wait for at least 2 seconds, and I'm going to put it as 3 just to kind of leave it on screen, to really rub it in that we've run out of time. So yield return new, wait for seconds, and in brackets 3 semicolon. And after 3 seconds, what we need to do is use that scene manager line. So scene manager dot load scene 1 semicolon, and save our script. So what we've done effectively here is start up our animations and our text to come on screen to say we've run out of time. And as well here we have said after 3 seconds we are going to reload. Now there is one extra thing that we will do before we actually test this out, because for the eagle-eyed viewers you may have noticed that indeed our player can still move around. So the reason that will happen is because we haven't actually turned this player control script off. So what we need to do is we need to reference the player inside our script, obviously the global time script. So heading back into there, let's now set the player as a variable. So public game object player. And what that means is that as soon as we hit 0, player dot get component, and in spiky brackets the name of our actual script that controls our player. So if you cannot remember what it was, you just go to your player and you'll see player controls. So that needs to be typed inside those spiky brackets. Player controls, open close bracket, dot enabled equals false, semicolon, and save. So what that will do is it will turn off the ability to keep moving our player, and obviously everything will function as normal. So let's head back into Unity, let the script refresh, load up, there we go, and now let's try this whole cycle out. Bashing those blocks, there we go. I think I probably should have reduced the time just a little bit. It's kind of, it's not wasting time, as it were. Right, so we should see this start to take effect any second now. So we cannot move our player. Oh, we can move our player. Do you know what I've done? Yep, that's right. I haven't actually set the variables. Do you know what? For those of you who actually follow me and have followed me for many years, this is one of the silliest things I always do. I need to pay more attention, I think. So all I've done there is just set those variables over there. So obviously, because we've added 3 new variables, Unity doesn't know what those variables are supposed to be. It just doesn't know at all. We're supposed to tell it. So what's essentially happened there is because I have not declared those variables, Unity has got completely confused and it has stopped executing the script as soon as it recognizes a line that it doesn't know what to do. So anyway, while we wait for this now, next tutorial, what I think we're going to do is we're going to create another way of getting game over. So we might have like a spiky pole or something. So we should end this any second. There we go. And you've not respawned. I know exactly why you've not respawned. So we didn't start the coroutine. Oh, that's classic, of course. I'm hoping you guys have already done that. So it's a little test for you there. My idiocy is a test. It's because we didn't start the coroutine. I implore you to leave a dislike for that one. So start coroutine, respawning level, open close bracket, semicolon, and save. So this is third time lucky, and I know it's going to work now. So let's press play, and I will tell you what we'll do. So I want like a spiky kind of pole in the next tutorial. So if we hit the spiky pole, we get game over and we have to respawn. That's basically where we're going to go from there. Should be kind of cool. And we'll see what basically happens. I think we might also add a fade in to our game as well. I think that'd be a really good thing to do. So let's hope that this works. Third time lucky. Third time lucky. And yeah, we ran out of time. And there we go. We've respawned, restarted. Excellent. We got there in the end, guys, didn't we? We got there in the end. So a fade in, as I explained in the last lesson, is basically a way of fading from black into our scene. Currently, our fade out lasts 2 seconds, but I would like our fade in to last just 1 second. So we're going to do this so as it plays a fade in animation every single time that we load the scene. So game object, UI, and raw image. And again, this works in the exact same way. So we just need to stretch the anchoring, zero everything out. There we go. And essentially, I guess you don't really need it to be black if you don't want it to be. It can be any color you want. I'm just using black as it's probably the most common color that you would see with fading. White is another common color if you want to use that. So yes, we need to keep this as the alpha as 255. So obviously the inverse of that would be 0, which is the fade out. So we need it to go from 255 to 0 during the course of the animation. And I'm going to change this to fade in. And what we'll do is we'll go to our animations folder, click on animation that we added in last time, remember that tab? And we'll click on create. Now what we'll do is call this fade in and save. And once again, we just need to press the record button. And we're in keyframe 0, which is the very first frame. So remember, what we need to do is reset this so as it acts as the first keyframe. So we can just play around with that and set it back to 255. And there's our first keyframe set. And as I said, we need this to last over the course of a second. So we need to set this to 60, obviously, because we're 60 frames a second. And now set this as 0 on the alpha. and close that and press the record button once again to stop the animation. Head to project, click on fade in our animations folder and untick loop time. We're not going to turn it off, we're going to keep it on. So as every time we play the scene, we fade into it. So fading in and out is really as simple as that. It's quick and it's easy. There's no drastic things you need to do. And with this kind of fade in, we don't even need to worry too much about scripting it. We probably will use a script a little later on in the series. It depends on how we establish different UI elements on our screen. But for now, we don't need to attach a script to this at all. So next thing we need to do is find a way of getting game over hitting a spiky kind of object. So let's zoom in. Let's double click on our ground to zoom in. And like in the same way we have previously with our coins, we're going to use the same kind of mechanic to manipulate it so as we can get game over. So we're basically combining several elements that we've previously learned into one single element. So let's go to game object. Let's go to 3D object and cube, obviously, because it's the most primitive and easiest object to deal with. Let's zero out the position and let's have it as 4 tall, and let's bring it upwards and let's bring it over here for now. Obviously it doesn't look very threatening, so we're going to use a cool little way of making it look a bit spiky, and that's just simply adding some extra cubes inside and rotating. Really cool idea. So all you need to do is right click on the cube and let's go to 3D object and let's go to cube and then uncouple the cube out of there. So drag and drop it just to there. Now let's have the scale set as 1 by 1 by 1. Let's have the rotation as 45 by 45 by 90. I guess we don't really need it as 90. Should we have it as 45 as well? It looks a bit strange as 45, so I might just have it as 0. So now we can see these little things protruding out of there. So I'm going to hold Control, press D to duplicate, bring it down a little bit, hold Control, duplicate again, bring it up a little bit, and then let's select all those three and just kind of bring them down to ground level a bit, round about there. So I think it's up to you. I mean, I've just done this nice and quick to kind of illustrate how we can create something that looks a little bit threatening. I'm just going to add a black material to it now. So let's go to materials, right click, create, and let's go to material down here. And we'll have this as black. And obviously we've dealt with materials before. We know what we're doing here. Let's set the color to black. And let's just drag the black material onto each of these. It's up to you what you want to do. You can make it shinier, you can make it darker. It's your game at the end of the day that you're creating here. So I'm going to leave mine as it is. So if we ever collide with this object, we want to be able to effectively die or respawn. So what I'm going to do is each of those interior cubes, I'm going to turn off the collider because we don't need it, and I'm going to place them inside the main column cube. And they do look a little bit crazy, so let's increase the size. Let's have it as 2 by, in fact we'll just have it as 1 by 1 by 1. They do look crazy. So this is one of the amazing quirks of Unity now. When you combine certain objects with each other, they go a little crazy inside each other. And to be honest, I'm happy with the effect that that's created. So it's entirely up to you how you want to deal with this. I mean, at the end of the day, as I always say, it's your game that you're creating here. It's not mine, it's yours. So I'll leave that as it is. So that looks kind of threatening, maybe, I don't know. But what I might do is I might attach the rotation to it as well. So I'm going to rename this as obstacle. Close that up, go to scripts, and we will attach the coin rotation. So I know it's not a coin, it doesn't matter too much, but at the end of the day, we can use this to our advantage and use same scripts for different things. And I'm going to change the rotate speed to 3 and see how this looks. Yep, so that looks pretty threatening, I would say. So now we need to write a script to allow ourselves that when we collide with it, we get game over. To do that, we're going to replicate this time up error. Well, error, I say it's a message, isn't it? So let's duplicate that. Let's bring it up to here, and we'll say hurt text. And we'll say you collided with an obstacle. And obviously that can be anything. You can make that text say anything you want. It's entirely up to you. So what we're going to do is we're actually going to duplicate our coin collect script. So hold Control, press D on coin collect. And you've opened it up for some reason, but that doesn't matter. And we just need to rename this to obstacle. I need to sort my caps lock out. Obstacle collide. And you will have an error. Don't worry about it too much. And let's open up obstacle collide script. And we just need to change the public class as well. Obviously, because whenever a script name changes, you need to make sure that you change the class name. So obstacle collide. Now, we don't need to have audio source on this, so that can disappear, which also means that we can get rid of this collect effects.play. We do, however, need to add in some more variables. And if we go to global time, we need to essentially replicate what we've done here. So we need to take these three variables from global time, which is time up text, fade out, and player. We can copy those and place them inside obstacle collide. Let's also change time up text to obstacle text. And heading back to global time, what we need to do is the same kind of thing. So we need to have these here. So everything from player all the way down to the start coroutine, let's copy those lines of code. And I suppose this lesson is all about how you can reuse a lot of code with just a little bit of modification. So all of those go inside that if statement, and you will get a couple of errors, but don't worry about those for now. So basically we're saying here, if the player collides with whatever object this will be attached to, then we turn off the player controls. We can get rid of the seconds because we're not dealing with seconds in this one. Time up text becomes obstacle text. Fade out will occur. And then there's the start coroutine, which we're going to call, in fact, we'll keep it as respawning level. And that also means that we can copy and paste this respawning level coroutine from global time and place it at the bottom of obstacle collide, and that will get rid of that error. Obviously, we need to add in the namespace because we're dealing with scene management here. So using Unity engine dot scene management semicolon and save the script. So let's review what is going to happen here. So this script will be attached to our spinning obstacle, and as soon as the player collides with it, we are going to turn off the player controls. We're going to bring on that obstacle text, we're going to fade out, and we're going to start this coroutine, which means that after 3 seconds, we are going to reload our scene. So let's head back into Unity, and all errors should disappear. And they do. So obstacle collide script now goes on our obstacle right there. And let's set those three variables. So obstacle text is the hurt text that we called. And I guess you can rename things at any point if you want to. Fade out goes on there. And obviously the player as the third variable. So let's try this out now. Of course, there is one extra thing that we didn't do. Have you guys spotted it? Hopefully you have. We haven't ticked his trigger. So let's tick it while we're in game now, and let's see the effects take place real time. So that is a nice little way. So I actually should say that is a nice little way of being able to see what's going on in real time. However, if we go into it now, it's still not going to occur because we've ticked it during play. So this is a nice little lesson to establish things that you can and can't do during real-time play. So we turned that is trigger on whilst we were playing in the game. However, when we stop or reload the scene, everything resets back to normal. So if we tick that now, everything should be fine. But if it isn't ticked and you do tick it during play, then you will have to re-tick it when you're not in play mode. Okay, we collided with Anne. Not sure who Anne is, but let's sort that out. Let's go to our hurt text. Let's change that. Let's set it back on. Let's double click to have a look. And we just need to lengthen that a little bit and realign it to the center right there. Let's turn it back off and let's check this out one more time. Cool. Still doesn't say it. We obviously need to extend it a little bit more. So hurt text, a bit more, and center it. Turn off again, one more time. Cool. You collided with an obstacle. And we respawn. So, I'm going to place a couple of these around now, just as some groovy obstacles. If people still use the word groovy, I'm not sure. Yeah, so you essentially can use pretty much anything. You don't have to use the weird twirly thing I've created here. It's entirely up to you what you want to create. There's no right or wrong. It's your game, as I keep saying. So, as I explained last lesson, I would like it to be at a point where we have collected, say, the 5 coins in the first level, and then we complete it. Now, there are a couple of things that we're going to have to go through to kind of work with these coins, because at the moment, when we respawn, we still keep the coins that we've collected. So, firstly, let's start by creating a script, which is going to be the script which will complete the level for us. So, let's right-click, create, C# script, and we'll have this as level complete. And let's open that up in Visual Studio. So there's a couple of things that we are going to want to deal with here, and I think in some ways it kind of resonates with the script that we've written in the past couple of lessons. So this script will ultimately take us to the next level, so we are going to need using Unity engine.scene management. Now, although we're not going to go to another scene with this script, at least in this lesson, we're kind of future-proofing here. So next thing we need to do is we need a variable to keep track of how many coins we've collected from that global coin script, because that way at least we are kind of updating and keeping everything inside one script. So let's have the variable named as, in fact, we'll have it as an integer first. We'll have this as imported coins, semicolon, which means that inside the update method, we now say imported coins equals global coins dot coin count, semicolon. And now we're going to have an if statement. So if, and in brackets, imported coins equals 5, then open curly bracket and do the following. So I want to wait for a fraction of a second after we've collected that coin, although I don't necessarily think we have to. Tell you what we'll do. We'll do both. We'll do it instantly, and then we'll wait for a fraction of a second, and then you can choose which method you're comfortable implementing. So let's start by having no delay, no waiting at all, and we'll write that as we go along. So if the imported coins is 5, then what we want to happen is pretty much the same thing as when we respawn, obviously except we're going to go to a different scene. So what we can do is we can go to the obstacle collide, sorry, and we can copy those 3 lines again, which are the variables, and place them in here. And we can get rid of the annotations and start. I don't think we need those. Let's change obstacle text to completed text. I keep knocking my little thing on my desk here. So completed text is going to be, say, level complete with some exclamation marks. In fact, let's save the script and let's actually make that now. You'll always find yourself going back and forth with Unity, into the engine, into scripting, into engine, into scripting. You'll do it quite a lot, so don't worry if you seem a bit confused. The fact we're going in and out, in and out. So let's take the hurt text that we did, duplicate it, and we'll change it to say level complete with some exclamation marks for good measure. And we'll have this as complete text. And let's bring that above the fade in. And we will go back into the script because essentially we now have everything we need here. We've got the text, we've got the fade out, and we've got the player. So that means that we can, on 5 coins, say completed text dot set, not send message, set active equals, not equals, in brackets, true, as we're setting it active, we're not telling it. Fade out dot set active also true. And rather than type, let's copy this line of code here. Player dot get component dot enabled false. That is from the obstacle collide script. So we've essentially done exactly the same kind of thing there. So we've collected 5. Awesome. So what we'll do is let's try out this simple script as it stands now. Let's head back into Unity. And we'll attach this script to our globals object. And let's attach those 3 variables. So completed text goes in there, fade out goes into there, and player obviously is our player. So let's press play. And we just now need to collect those 5 coins. 1, 2, 3, 4, 5. There we go. Actually, do you know what I think? I think that should be okay. So, level complete again. Now, what we need to do here is we need to add in a coroutine. So, I enumerator, and we'll say level completed, open close bracket, open early bracket, and we will yield return new, wait for seconds, and we'll wait for the 3 seconds that we usually do, and then the next line of code would be moving to another scene. Obviously we don't have that next scene yet, so we're going to have to come back to this script later on when we do have the scene. So we need to put here start coroutine, and in brackets level completed, open close bracket, semicolon. And I'm going to save that script now. I did say that we would work out if we are going to wait a couple of seconds, or rather a fraction of a second, after we've collected that coin. And to do that, all we need to do is take everything above the coroutine, so those 3 lines, cut them out of the if statement, and start the coroutine right there, and then let's say yield return new, wait for seconds, and in brackets that fraction of a second, whatever you want it to be. So let's say 0.2 f semicolon and then those 3 lines of code, and save. So now we've waited for, in this case, 1/5 of a second before we start that process of moving on to the next level. So you should see a very slight delay after we've collected that 5th coin. There we go. So again, it's entirely up to you which one you want to go for. So finally, let's encompass our level with some walls, just so things don't go outside the boundaries. And to be honest, we can do that in a real quick and easy way, and you don't necessarily have to. Once again, it's entirely up to you how you create your world. So I'm going to go on the ground, hold Control, press D to duplicate, I'm going to put the scale to 20 on the Y and 1 on the X. And I'm just going to bring it to about there. And rename that as wall. I'm going to duplicate that once again and bring it over the other side. And let's keep that as wall as well. I'm going to duplicate ground once again, set it to 20 and 1 on the Z, and take the wall towards the back. And rename that as wall. So now, if we press play, it looks like it is all inside this little world. And as always, it's entirely up to you how you want to deal with this. You can miss this out completely if you want to. And see the cubes? They just won't go outside the boundaries. So you could effectively have this all the way down here. You could have the ground all the way down here. It's really entirely up to you. You don't have to do what I do, but your game. So yeah, I'm quite happy with how that looks now. So when we pause the game, the good thing is we're actually controlling time itself. And because we have our timer set up based on time itself within Unity, we don't actually have to do anything with it. It will automatically pause whenever we tell Unity to set the time to 0. So it's kind of handy in a lot of ways. So the idea what we're going to do here is we're going to create a script first, which will pause the game. After that, we are then going to design a quick little pause menu and apply everything together and make sure our game pauses. So let's start by creating the script. Let's right click, create C# script. We'll call this pause game. And let's open that up in Visual Studio. So generally what we need to do is create an if statement to say if we are pressing the cancel button, or escape as it's known, then we will be able to pause our game. If our game is already paused and we press it again, then we automatically unpause our game. So we just need to make sure that the script, I should say, knows whether we are paused or whether we are not. So to do this, let's start by creating two variables. One is going to be that bool to check whether it is paused or not. The other is going to be our UI pause menu. So we don't need void start and annotations, they can go. We do, however, need the update method. So let's start by declaring the boolean as the variable. So public, and it's going to be bool, and we'll call it game paused. By default, we will make it equal to false. And the second variable is going to be a game object, which is going to be that pause menu that we will create. So public, game object, and we'll call this pause menu. We are also going to deal with the music. However, the music is attached to the game object that this script will be attached to, so we don't need to declare that as a variable. We can easily access it. So in our update method, we now need to put an if statement to say, are we paused? Are we not? And also outside of that, we need to check if we are actually pressing the correct button. So we're going to nest a couple of if statements here. So let's start by saying if input dot get button down, which is right there, and in brackets and quotes the name of our button that we are trying to get here. And I will show you where this is, but by default it's always called cancel. That's the escape key. So if this is indeed your very first game in Unity, you won't have any problems typing this here. If you've changed things, like I say, I'll show you where they do get changed later on, then you may need to put a different word here, but generally the word cancel will do the trick perfectly. So two close brackets there and open curly bracket. This is where we are now going to nest another if statement. This next section is going to check whether our game is paused or not. So we can put if, and in brackets, game paused equals false. So we're saying here, if the game isn't paused, then we set the time scale, so time dot time scale equals 0, semicolon. So what that's doing is basically freezing everything. So time runs at a constant of 1 by default in Unity unless you change it. So 0 and 1 are those absolute numbers that you use for either stop or go. Obviously you can change things to speed things up, slow things down a little bit, but we're not doing that here. We are just pausing and resuming the game. So timescale is 0. Next, we have to say that the game is paused. So game paused equals true, semicolon. And we are actually going to put the cursor as visible. So the reason being is because we're going to have buttons on our pause menu at some point, probably this tutorial actually. So we're going to need to be able to use our mouse. So we do need to put cursor dot visible equals true, semicolon. Then what we're going to do is we are going to pause the music. And to do that, we need to reference the audio source that is on this game object that the script will be attached to, which is our globals object in the hierarchy. So we can put this dot get component, and in spiky brackets, audio source, right there, open close bracket, and we are saying dot pause semicolon. Oop. That should be open close bracket semicolon. So we're saying get that component and pause it, which is all good. Next, we need to display that pause menu, and that's just a case of setting it active. So pause menu dot set active, and in brackets true, semicolon. So if we press our cancel button, the escape button, it will pause now. And obviously we now need to do the complete inverse of that. So we are going to need an else statement below it. So else, open curly bracket, and like I say, do the inverse in reverse order. So we can take this line, pause menu, set active. So let's set that as false. We then need to unpause the music. So we can take that line of code, place it here and put unpause. So the music will resume. We then need to have the cursor invisible again. So cursor.visible equals false. Game pause now becomes false once again because we have resumed. So game pause equals false. And the final thing to do is reset the timescale back to 1 and save the script. So creating a pause function in the game is really as easy as that. There's nothing special about it. All we're doing is detecting whether we are pressing the escape button and if it already is paused or not. So we can head back into Unity now and just let it compile. And there we go. Now, before we test this out, we are going to add in a quick little pause menu. So let's go to game object. Let's go to UI and let's have something different, shall we? Let's have a panel. Now, a panel works in pretty much the same way as every other thing in Unity's UI system. You can see it kind of covers the entire screen. We don't want it to cover the entire screen. We want it to be centered. And we want it to be, well, as big as you want it, really. And it's entirely up to you. So if we place it there and have a look at our game view, that will be our pause menu. So let's make it more than just a panel right now. Let's have this as pause menu. And let's add a couple of things in there. Let's add some text. So let's right click on pause menu, go to UI, click on text, and we'll have this as paused. And let's have this anchored to the top. Zoom in a little bit. And let's have the font size as 30. Let's also have it white. And let's have it aligned to center. And let's bring that to there. So currently our pause menu looks like that. So now we're going to need a couple of buttons on there to say resume game, restart, quit to menu. So let's right click on pause menu again. Let's go to UI and let's go to button right there. Buttons are a little bit more complicated when it comes to UI. They're not as simple as just inserting some general UI. They require a little bit more to it. So buttons is probably going to be something we cover in the next video. For now, let's just click here on the button, click text, and we'll just call this resume game. And let's hold control, press D to duplicate that button. Let's bring it down a little bit. And we will click on the arrow again and change the text to restart level. And we'll have one more button, which is going to be called quit to menu. So let's change the text on that one to say quit to menu. And let's quickly rename those buttons. We'll have that as resume, restart, and we'll have that one as quit. And I'm going to close all them up, have a quick look at the game view. It's not perfect, but it will serve its purpose just for now, until we really get into the bits of how buttons work and refining our pause menu. So let's have our pause game onto the global object. So drag and drop onto there. Let's also turn the pause menu off. Let's go back to globals and scroll down, and you will see right here we have pause game script. So the pause menu object that we've just created becomes that variable. And now if we press play, so our game is indeed paused. We can't actually do anything. We can move our character around a little bit, but you'll notice that overall the time has indeed stopped. So everything that is rotating, they are still rotating because they are not directly linked to the time scale. So if we press escape again, our game does indeed carry on. So you can see everything is working as intended there. If you want your coins to stop rotating, then what you can do is if you go to coin rotation, for example, and we have rotate speed. Now, to make them basically stop when time is stopped as well, because it does look a little bit silly as it is right now, all we need to do here is say multiplied by time dot time scale. And save that script. And what that will do is make it so as if time is 0, then anything multiplied by 0 is 0, so nothing will rotate here. So we can see this in effect when we press play and try pausing once again. There we go. So you can see now everything has stopped, because don't forget we attach this script to these obstacles as well. So that's why they have also stopped. And there we go. Paused. Unpaused. So up until now we have a nice simple script that whenever we press the escape button, also known as the cancel button, it will indeed pause our game, bring up a menu, and if we press it again it will unpause and make that pause menu disappear. So we want the buttons on that menu to function, well, as they should do. For example, when we press resume, we want the resume to actually occur. So to do that, we need to go into our pause game script. And all we really need to do here is replicate these few lines of code and make everything work as it should do. So to do that, we need to create an extra method, one for the resume and one for restarting the level. Now, the way these methods work is exactly the same as a standard method. However, the button needs the method to be public, otherwise it can't technically read it. So for the button to be able to read a method, you can think of it as the method just needs to be public, and the method can be called anything you want. So let's go beneath the update method and let's have the word public void. And we'll call this unpause game, open close bracket, open curly bracket. And as I said, we just need to replicate these few lines of code in this method. So literally copy and paste. So we can actually use this to our advantage because regardless of whether we press the resume button or whether we press the escape button, the exact same thing will occur, which means that we're not going to have any errors should we want to pause it again afterwards. So that's how resuming the game works with a button. But how do we restart the level with a button? Well, it's pretty much the same thing as what we did with our global time. When we run out of time or whenever we die, we can just use the same lines of code there. So let's create another method for that other button. Public void restart level, open close bracket and open curly bracket. Now, because we're going to be dealing with scenes here, we do need to add in at the top the namespace using Unity engine dot scene management semicolon. And if we head to our global time script, we will need to copy this line of code right here, because that line takes us to our respawn scene. So let's place that line of code into there. Now, one extra thing we will have to do here is we will have to set the timescale back to 1. The reason being, if we don't, you will basically respawn in your level, but nothing will happen. Everything will be completely frozen because you are still setting the timescale as 0. You're never resetting it back to 1 on this button press. So you have to make sure that we take that line of code and place it before we change our scene. So time.timescale equals 1, semicolon, and save the script. So all we've done here is create 2 methods for 2 buttons, and that's as easy as it is. It's as simple as that. The next step is to apply those methods directly to those buttons, or rather tell the button which set of instructions it has to follow if it is pressed. So let's head back into Unity and let's let it compile. All good. So remember, it is on the globals object and it's down there, pause game. So let's go to our first button in Canvas, and it is the resume button. Now down here, you'll notice it says list is empty. We need to create something in here. So let's press the plus button. We now need to define which object the set of instructions is going to be on, and it's going to be on globals. So drag and drop to there. You'll notice this no function here highlights. Let's click the drop down menu, and rather than no function, we want to go to our pause game script, and we want it to run unpause game. So what we've done here is we have told this button that whenever it's clicked, we need to run the set of instructions that is in the unpause game method that is contained in globals. So we can do the exact same thing for restart. Let's click on the plus. Let's drag globals over here. No function is lit up, so let's click the drop down menu. Let's go to pause game, and we want to restart level with that second button. Now, both of those buttons have a set of instructions assigned to them whenever we click them. So let's give that a go. So let's press play, go into our game. Let's pause the game, and now let's resume. And there we go, we've now resumed our game. Let's try that again. Excellent. So let's try it. If we pause the game, and now let's just unpause with the escape button. Excellent. Still works. Now let's try restarting the level. Perfect. We've now restarted. So one last thing that I am going to quickly do is fix this little issue that we've had for a while now, which is our score. So let's restart the level, and our score still remains 3. So we now need to come up with a way of resetting that score every time we restart our game. And we can actually do that on the respawning script itself. So if we go into the respawning script, and all this one does, if you remember, is basically just takes us to whatever scene we're on as soon as the scene loads. So let's put an extra line of code before we go to our load scene. So we need to reset our score, and that is in global coins. And we need to reset this one right here, coin count. So in respawning, we need to say global coins dot coin count equals 0, semicolon, and save. So it's always going to be a 0 because whenever we enter this particular scene that this script is attached to, we're always going to be going to a new level. Therefore, our score should always be 0. This way, it resets the score before we even get to our level, so it's ready for us when we get there. So let's head back into Unity and just make sure all of that works. So let's restart now, just to make sure it's all good. And let's collect a coin. And now let's restart. And our score is back at 0. Excellent. Let's collect a couple. And restart. There we go. Awesome. So, next tutorial, what I want to do is I want to get this button working, the quit to menu. And that involves us creating a main menu, which is going to be a bit of fun. So we're going to come away from developing in this main scene, at least just for now, because we're going to put together a main menu that's going to have buttons. It's going to look, I guess, however you want it to look. Maybe we'll come up with some cool effects. And we'll also make some buttons on there, and obviously they'll need tying together. And then we'll get this quit to menu button also working. So everything should come together, at least somewhat nicely. There we go. So a main menu you could think of as being as simple as creating that pause menu that we've created, but on a slightly larger scale. And that requires an extra scene in itself. So let's go ahead and create a new scene. So File, New Scene, and let's save that scene as Main Menu in our Scenes. Main Menu. Now, there are many different ways of creating a main menu, and I don't think it's necessarily a right or wrong way of doing it. I think it's probably something that you could work with, but all I'm going to do is I'm going to create something very simple and have a couple of our little animals just there in the background. So I don't want to waste too much time designing a background because you can probably do this yourself. But essentially, all I'm going to do is create a couple of game objects. So a large cube, let's have that centered. Let's zoom in so we can see it. There we go. And let's change the scale to, let's say 50 by 50, so it's quite long. Let's go ahead and fix our lighting. So Window, Rendering, Lighting, and let's click on Generate Lighting. There we go. And now let's apply a material. Let's just have a red material. I might create a blue one as well and have that as a background. So let's duplicate that red material, blue material, and let's just quickly change it to a blue color. Let's duplicate this cube, and I'm going to have this as 50 tall, and in fact I'll keep it that way and I'll have it kind of as the background that way. And let's have that as blue. Let's take a look at our camera. So that's currently what it looks like. So our main menu coming together somewhat reasonably well. So let's put our little creatures in the scene just to add something extra to it. So mesh, let's have the chicken. Let's turn him around. Bring him to there. Our dragon, let's have him, in fact we'll have him as that way. Drag him out to the ground a little, and the condor. So let's have him facing that way, maybe up here somewhere. Oh, hello, there he is. So I'm going to drag the camera out to about there, move it across, bring it up to probably about there. So that is basically the background of our main menu, and you can have it as a UI image, you can have it as moving up, you can have it as anything. Realistically. Let's see what this looks like. Okay, so maybe we should add some quick animations to these guys. I think it would probably be a little better. So let's add the move to there. Let's add move to there and move to there. And they should now start flapping a little bit. He's bobbing up and down. Okay, so it's up to you what you want to do. If you want to do exactly what I've done, fair enough, but let's get into actually making some of the main menu itself. Now, the way I want to design this is I want to have like a bar coming down here that's slightly faded with some buttons on. And again, it's entirely up to you what kind of method you want to create here. So let's go ahead, go to game object. Let's go to not 3D object, UI, because this is all UI based. And let's go raw image. I want to anchor stretching all the way across, up, sorry. And let's have 0, 0. Let's zoom out so we can see. I'm going to change the color to black and change the alpha to 100. And I'm going to use my rect tool and just bring this out to about there and place it there. Maybe a little bit more this way. So we also need to set the canvas here to scale with screen size, which means we might need to bring this back a little more, shrink it a bit. And we'll set this as 1920 by 1080 and we'll set it as 0.5 so it's dead in the center. So it'll scale to any screen size that people are running. Okay, so now let's create some buttons. So let's go game object, UI, let's go button. Now this button will be start game, so start button. And let's zoom in and let's refine it a little bit more than what it currently is. So I'm going to have this one as the first button at the top up there. Let's make it a little bigger. There we go. And let's play around with the font size because it is a tiny bit small. So let's have this as 36 and we'll have play game. Now the button itself, let's see what we can do. Let's have normal color as a dark, deep greenish kind of color maybe. And let's also have the text as white so we can see it a little better. So when we're hovering over, so highlighted, it's currently a very light color. But what do we want it as? I think we should have it as, let's have it as black. So highlighted color, let's go with black. So whenever our mouse hovers over that play game, it will turn it completely black. And obviously if it's not hovering, it will go back to its original color. Cool. Pressed color. So whenever we press the button, we want it to change color. Let's have it change to a lighter green. So again, if we press play, we should be able to see. Cool. So now you can see that it is indeed selected and it has turned kind of a grayish color. But that doesn't matter too much. I think we should have the selected color as a deep gray rather than a light gray. So you can play around with these color settings as much as you need to. You can obviously go a lot further with this. You don't necessarily have to just stick with these colors. There are many, many different ways you can deal with buttons in Unity, and it is definitely worth playing around with them a little bit. You can also change this to maybe different types that you want to see, make it a round button if you want to, but you can also apply your own sprites to this and make the button look exactly how you want to. Seems we're going just for simplicity here. I'm not going to worry too much about that, but by all means you can if you want to. So the next button that we're going to have is going to be a load game button because yep, we're going to have saving and loading in the series. So let's hold Control, press D to duplicate that button. Let's bring it down to there. And let's change the text to say load game. And let's change the name of the button to load button. And finally, let's have quit game button. So duplicate, let's bring it down to there. And let's have this as quit button. And the text, quit game. So whenever people have had enough and they just want to quit the game, boom, press the button, done. Let's change the colors. So load game, let's have that as a bluish kind of color. So a light blue color there. And quit game, let's have that as a reddish kind of color. There we go. Let's press play and have a look at this now. Cool. So, what else can we do with this? Well, another thing I've noticed with a lot of menus, not necessarily these days, is they have like maybe a bar at the bottom with some information on. Let's create one of those. So we can duplicate this raw image and let's change the anchoring so it stretches across the bottom right there. And let's place this down the bottom and let's just realign it with our rect tool. Bring that to there and across to there. And that's how it'll look there. So maybe we can have some text along here saying, what level we're currently on or something like that. So for now, what we need to do is we need to get these buttons working a little bit, at least the play game button. So the load game button we will work on when we get around to saving and loading functions. And obviously we'll code the quit game button this tutorial as well, but it won't actually work just yet because the quit game will only work when you're in the application itself rather than the engine. So let's go to our scripts folder, right click, create, and let's go C# script. And this will be main menu. So everything that deals with the main menu will be within this script. There we go. So what do we need here? Well, there are 3 buttons, so it means we're going to need 3 separate methods. Let's get rid of void start and void update. But let's add in using Unity engine dot scene management semicolon. So let's start by creating those methods. Public void start game, open close bracket, open curly bracket. The next one is going to be public void load game, open close bracket, and the curly brackets. And finally, public void quit game, open close bracket, open curly bracket. So let's start with the quit game. This one is real simple. It's just application dot quit, open close bracket, semicolon. So all that will do is whenever we are in the application itself, so when we've built the game and when we're running it, if we press that button, it will indeed quit the application, but it won't do it in Unity, like I say, because that's the engine. It can't physically quit the engine. So let's do the start game button. And this one is real simple. This is just going to be scene manager dot load scene, and I'm just going to have the 2 brackets there, the parentheses and semicolon, and save our script. I know it's going to give us an error, but we now need to play around with our scenes just a little bit. So we're going to have, before this scene, a splash screen as well. So theoretically, the main menu is now going to become scene number 1. And I think we'll probably end up changing it in the next tutorial anyway. But for now, I'm going to go to File, Build Settings, and click on Add Open Scenes. So now you can see that we have 0, 1, and 2. And like I say, I want main menu to be scene 1 by the end of the next video. And I want our splash screen to be scene 0 by the next video, which is obviously what we're doing then, which means that our main scene, which is still called sample scene, which we'll end up renaming, will eventually become scene 2, and respawn will become scene 3. So that's just a quick heads up of what we're going to do. But for now, all we need to do is make sure that play game actually works and it takes us to the correct scene. So let's go 0 and save, and that will indeed take us to the correct scene. So let's head back into Unity. That error should disappear down the bottom, and it does. So now let's press play and play game. Oh, just realized we haven't actually set the button. There's a good example of the button not knowing what it needs to do. So let's go to start button And remember that we need to add this section here, but we also need the game object with the main menu attached to it. So game object, create empty, and we'll call this menu control. And let's attach the main menu script to it. And we don't need to declare any variables because there aren't any, but let's go to start button. Let's click on plus. Let's drag menu control over. Let's click no function, main menu, and start game. And while we're at it, we may as well set the quit game as well. So plus, menu control, no function, main menu, and quit game. And now let's try this out. So main menu, all good. Let's play game. And there we go, straight to our game. So next thing we need to do is sort this button out, quit to menu. Let's sort that out now. Let's go to our other scene, which is, oh, that's very handy. I forgot it creates extra folders there for you, so don't worry about that. If you do see extra folders appearing, that just relates to the menu itself because we've basically generated the light, so don't worry about that. Let's go to our main scene. Yes, save changes on that one. And let's go to the canvas and let's go to pause menu, and the quit button is what we're dealing with here, remember? So let's make sure we go into our pause game. There we go. And it's going to work the exact same way as what we've done here with this restart level. So what I'm going to do is I'm going to copy that method, place it down here, and we'll put just quit level. Obviously, we need the timescale back to 1. We can't keep it at 0, and we do need to have the scene as currently 2. But like I said before, we will change it when we've got everything in place. So let's save that script, head back into Unity, and let it compile. Let's go to our quit button, click plus, drag globals across, no function, pause game, and quit level. And now let's try this out. There we go, and we are back at our main menu. So that will inevitably just cycle all the way through whenever you click the buttons now. So we have all that set up. So you may have already noticed that I have brought in an extra texture just here. Now, I'm not going to distribute this because simply there's no point. But if you want to use text to create your splash screen, if you want to use an image to create your splash screen, if you don't even want a splash screen, I guess it's entirely up to you. I'm just going to use this logo that I've had created for many years now, but again, you can use anything you want. So what is a splash screen? A splash screen, in its simplest terms, is just a quick little screen that displays your name, your publisher, your developer, whatever you want to call yourself. That would be the screen to normally show it. So some games have a couple, some games have one, some don't even have any, I guess. But we have to keep in mind that if you are using the free version of Unity, you will end up with at least one splash screen. That one splash screen will be the Unity logo itself. And if you do play Unity games from Itch.io or somewhere, you probably will have seen it at least on a few occasions where the Unity logo is always the first splash screen to appear. Well, we're going to create the secondary splash screen, which, like I say, is the logo. So quickest, simplest way to do it is create a new scene. So file, new scene, file, and save as in our scenes folder. And we'll call this splash screen. Now, we've done it on a couple of occasions where we have created just a black background, and that's exactly what I'm going to do here. My intention is just to have this logo kind of fade in and then fade out. So we're creating a small sequence of events in this tutorial. So let's go to game object, let's go to UI, and let's go to raw image. I'm going to have this anchored, stretched all the way, 0 on everything, and I'm going to have it completely black. Next thing, I'm going to add another image. So game object, UI, raw image, and this one is going to be centered, and let's keep it center. And I'm going to extend it outwards a little bit and then apply the game logo to the texture right there. And we can see that is pretty much how it would look. So in its simplest terms, there's our splash screen all good to go. But most, if I can get my words out, most splash screens have some kind of animation. They look a little bit different. They're not just plain like that. So what I'm going to do is I am going to create an animation for it. And I think I'm going to have it fade in and rotate at the same time. So what I mean by that is if I change the rotation on the Y, you can see it turning like so. And although it's not going to make too much of a difference in the scene view, when it comes to creating it on the game view, it will indeed look kind of different. It won't look like that. So I'm going to have that set as 90. And if we go to game view, it's not even there. Even though we can see it, technically it's there. Because it's a 2D texture, there's no third dimension, so we can't see it. So I'm also going to change the alpha to 0. Now, this is going to be a cool little interesting piece that we do here. So I'm going to rename that raw image to just JV logo. And obviously you can do this with anything, any image, any text. You do what you want with it. It's your game at the end of the day. So let's create an animation for this. So animation, create, we'll call it splash intro. So what I'm going to do is I'm going to make that kind of spin and fade in over the course of a second. So let's go 0 and set our first keyframe. So that's going to be everything that we have it set as now. So 0 on the alpha and 90 on the Y rotation. So after 60 frames, we want it to be rotated to 0, and we want the color to be completely opaque. So I'm going to leave that on screen for, let's say, 4 seconds, should we say? So then that's 240 frames. So at frame 300, we are then going to set the exact same again. So reset to 255, and let's put 1 on the Y and then 0 again. All that does is just resets that keyframe, and if we scroll along, we should be able to see it has indeed set that keyframe. Now, after another second, I want it to rotate once again and fade out. So let's set that as 360, and let's set this to -90, and let's set the color to 0 on the alpha. And let's press the record button to stop. And let's go back to our project window, click splash intro and untick loop time. And let's press play and see how that looks. Okay, fair enough. Cool. So, like I say, a lot of splash screens always have a little animation, and you can do anything you want. That's just a cool little animation that I've put together there in, what, 2 minutes maybe? Less than 2 minutes? So anything you want. Now, let's create the sequence. But first, let's actually add this scene to our scene build. Now, the reason we're going to have to do this is this splash screen will always have to be scene 0 because it's the first scene that loads. So let's go to File, Build Settings, and Add Open Scenes. Now, if you remember last time, I discussed about reordering these and putting them in a final order. This is what we're going to have to do, because splash screen is going to be moved to the top, which now becomes scene 0. Main menu is now going to become scene 1. And the sample scene, which we will end up renaming, as I've said, is going to be scene 3. So scene 3 onwards are going to be all of our actual levels. So the first one, like I say, is going to be the splash screen. So we need to create a script to take us straight into the main menu after the 6 seconds that we've been on the splash screen. Remember, it is 5 seconds until we start fading out again. So it's 6 seconds on this scene. So let's go to our scripts folder and let's right click, create C# script, and we'll call this splash to menu. And let's open it up in Visual Studio. So this again is going to need the namespace in there for the scene manager. So using Unity engine dot scene management semicolon. We can get rid of the update method. We don't need it, and we can get rid of annotations. This is going to be done inside a coroutine, again, because we have to wait for 6 seconds before we can actually do anything, because we want our splash to display. So what we need to do is say enumerator, and we can call this anything we want, within reason, obviously. We'll call this proceed to menu, open close bracket and open curly brackets. Shouldn't put a space there. So we're going to wait for 6 seconds. So yield return new, wait for seconds, and in brackets 6. And then after 6 seconds, we're going to say scene manager dot load scene, and in brackets scene number 1, because 1 is now permanently our main menu. Now to start this coroutine, we need to state so in our start method. So start coroutine, and in brackets proceed to menu, open close bracket again, semicolon, and save. So that's all there really is to it. It's a very, very small sequence of events, obviously, because there's not a lot going on in this scene. And it doesn't really matter too much where we attach this script, so I'm just going to go ahead and attach it to the camera. Because realistically, there's no point adding an extra game object here when we can just indeed attach it to the camera. So let's save our scene, let's press play, and let's make sure that this does indeed work and take us to our main menu. And there we go. We are on our main menu. Cool. So everything is going to go a bit haywire from here, as you can see. So if you start clicking things, it's going to take you different places now. So that's why we need to sort out the linking at this point. So we now have the final order of what our scripts, our scenes are going to be in. So we need to modify the scripts to reflect that. And that's not too difficult in all fairness. The best way of going through with all of this is to go to your scenes. And let's go to main menu. Now in here we have a couple of items in our main menu. So let's click on the main menu there. So start game, that now needs to take us to, you can either do this, because this is going to be a brand new game, you can either do this to scene number 2 or 3. Both will end up with the same thing happening. So if we do 2, it will take us to our respawn scene. If we do 3, it'll just take us directly to the scene anyway. So I think for all intents and purposes, we'll keep this as 2 to keep everything uniform. So let's make sure on our main menu, start game method takes us to scene 2. That's good. Now what we need to do is go through. In fact, we will load up the other scene just in case. We'll go through the scripts that are involved with this scene and just make sure that they all link correctly. So the camera follow doesn't need any change. The coin collect doesn't need any change. Coin rotation doesn't. Global coins doesn't need any change either. Global time will. So let's go into global time and make sure we have the correct scenes labeled and put down here. So here, respawning level, we're being taken to scene 1, which is the main menu currently. We want to go to the respawning scene. So that means we need to change that to 2 and save. Okay, so going along to our next script. Level complete. I don't think we've got anything in there just yet, have we? I think we future-proof that ready with the Unity Engine.c management, because we're going to be doing that probably next tutorial, creating next level. Main menu we've sorted. The obstacle collision, I do think we need to change, if I recall correctly. Yes, so respawning once again needs to be changed to 2. So that's now relinked correctly. Pause game. I believe that one will do as well. So let's check we've got everything correct here. So unpause game is fine. Restart level will have to take us to scene number 2. Quit level. Now this can either take you back to the splash screen itself or the main menu. So you can either put 0 or 1 for this one. I'm just going to go to 1, go straight to the main menu, save a couple of seconds. I guess there's no real point going back to the splash screen unless you really, really want to. So that is the pause game set. And it's just updating. There we go. We don't need to do anything to play controls. Respawning. Yes, I do think we need to. So when we respawn, we need to be sent to, currently, it's going to be number 3. However, we are going to deal with this a little bit more later on in the series because we need to be able to know that we actually are respawning in level 1. Because if we respawn in level 2, keeping it as 3 is just going to respawn us in level 1. So we're going to need to modify that a little later on in the series. But for now, for all intents and purposes, we only have 1 level. So scene number 3 is fine. And the last script is that splash to menu that we've created earlier. So I'm going to save that now. And I'm going to try and hope and pray that all of this works as intended. So let's go to our splash screen. And let's press play and let's go through all of these linkings, all of these sequences, and just make sure everything works as intended. You'll find yourself doing this quite a lot throughout development, doing the same things over and over. Let's resume and then let's restart. That's fine. Let's quit to the menu. Okay, so it looks like everything is linking correctly, so I'm happy with how that's now looking. So creating levels is kind of fun when it comes to game development. I think everybody to some degree must enjoy it, well, to some degree I guess, because otherwise we wouldn't be here. So let's start by actually renaming this sample scene finally, and I'm going to call it level 001. Now I'm kind of going to cheat a little bit, and I'm going to use that as a base for the next level. So I'm going to hold Control, press D, and I'm going to rename that to level 002. Let's open up level 002. So first things first, I want to be able to differentiate between this and level 1 because I'm not going to do much to the design of this level. The intention of this video is to kind of take us from a completed level 1 to a completed rather a start of level 2, I should say, and being able to respawn in level 2 and going to level 2. I'll demonstrate all the problems that we have along the way. So in order to do this, what I'm going to do is to give us a definitive different feel to the level, I'm actually going to change it from red to blue. So I'm definitely 100% in scene number 4 in this case it'll be, but this is level 2. So I'm going to change everything to blue. There we go. Let's also move a couple of these things around a bit just so as it very clearly is a different sort of level. Let's move them over there, and let's probably move the coins around a little bit. Let's put this one here, let's put this one over here, and let's put this one over there. Okay, so now we definitely have level number 2. So if we were playing this, yep, that's all pretty good. So if we wanted to resume, we indeed can. However, if we restart, we end up going back to level number 1. So this is where we have to create a global level script. So what we're going to do, the sequence of what we're going to do in this video is create that global level script, apply it to level 1, and then apply it to level 2 so as everything becomes seamless. So let's go to our scripts folder. Let's right click, create, C# script, global level. Now we can use this to our advantage. So if I just go, there we are. We have it open now. So we can use this to our advantage because if we set the variable in this particular script to starting at 3, it means that we can then use that variable in multiple other scripts, and we can always reference this script if we ever change levels. So I'll show you what I mean. So let's start by adding a variable. So public, and we're going to do the same as what we've done with the coins here. We're going to make it static. It's going to be an integer, and we'll call this level number. And by default, like I say, we'll make it equal to 3, semicolon. Now, what we need to do is we need to be able to update whatever number this will be. And I guess you don't necessarily need this to occur. You could put it in update if you want to, but for all intents and purposes, we will have it in here to kind of see what the actual number is. So level number, in fact, we will change that because we'll need to add in a variable. So public int, and we'll just call it internal num. Again, you don't necessarily have to do this. It's just a case of being able to see in the inspector panel what the numbers are, and we can probably remove it later on in development. So all we're doing here is saying that internal num equals level number, and the reason we're doing this is because a static value will not appear in our inspector panel. So if we ever want to have a quick reference to look at, we can just do that. So let's save global level. Let's head back into Unity, and firstly, let's start with the main menu. In fact, no, let's add this scene first. So let's go to build settings and add open scenes. Now you can see that we are going down the order. So 3, 4. So now that's in there, let's head to our scenes. Let's go to main menu, save scene, level 2, I should say. Now, this is where things become interesting. So we're going to add our global level script to our menu control. And you should be able to see right there, internal num. So if you press play, it will change to 3. Now, if you recall, 3 is the scene number that we travel to on the main game itself. So that is the very first level. So here, we can either keep it as 2, because this button will always start a new game, or we can actually change it to global level dot level number and save. So rather than put an actual number here, we're referencing a number that is in a different script. And like I say, we can use that line of code, the exact same line of code, in many, many different ways now. So if we go to respawning, let's now change that from 3 to global level dot level number and save. So again, this will always be 3 unless we change it. So the reason why it's so important to do this in the respawning script is because we now don't need multiple scripts to do the same thing. We can just use one single script and change this variable depending on what scene we want to go to. Same thing will apply to the global, not the global coins, the I've lost the script. So this one, obstacle collide, that will always stay 2. So this is what I want. This is what I'm trying to explain here. This needs to stay as 2 because that scene is always going to be static. It's always going to be the same scene that we go to whenever we actually hit something that, you know, kills us or whatever. And it's then that scene that sends us to the correct scene because we'll have set it prior to the game starting the new level. So in order for all of this to come together correctly, we now need to go to level complete. And remember, we've already set this as saying the scene management is up there, which means that yes, we can indeed go to our next scene. However, before we do that, we need to add one to our global level script. So global level dot level number plus equals 1 semicolon. After we've added 1 to it, we now need to send ourselves to that level. So that means we can say scene manager dot load scene, and in brackets global level dot level number, semicolon, and save. Now, we have to make sure that we do all of this correctly. It's always a good idea to apply that global level script to any scene that would need to reference it. So in this case, we have it on the main menu because we're going to need it there, because that takes us to scene number 3, which is level 1. So let's go to our scenes, let's go to level 1, and let's apply the script there as well. And there it is somewhere. I've lost it, global level. So that goes on our globals. That should be down the bottom. Yep. Now let's go to level 2. Make sure we save our scenes. And let's do the same there. We need to attach our script to the globals object. And there it is. Make sure we save. Let's go to our respawn level. And I'm just going to attach it to the camera on this scene. Again, because there's not a lot going on in this scene, it doesn't really matter too much. So there's the respawning script, and there is the global level script. So save. Now, one thing I will say when testing this, if we go to level 2 and try testing level 2 and restart in level 2, the problem is this script will always load up 3 because we've not predefined it to load up scene number 4. So just to show you what I mean. So if we do that, restart, it will take us back to scene number 1. However, if we go through the sequence of events that would be the person playing the game, then yep, we're here. We're on level 1. Let's collect all these coins. Level complete. Excellent. And okay, so you can see already that we do have a little bug. And you can see down the console that we have an error. So we've come to a point where we have possibly known as an infinite loop, where it's just kind of cycling through things that it really shouldn't. And I think the reason that is happening is because we are keeping our coins and not resetting them. So I'm now thinking the best thing for us to do is no matter what, under any circumstance, if we take ourselves to the respawn scene, I think that will erase any possible errors. So I'm going to go to console, clear, back to project. Let's go to our script for completion. So level complete. And rather than go there, I'm thinking we should just go to scene 2. So what this will do instead is it will add 1 to our scene number and then take us to the respawn scene. That respawn scene will take us to the correct level. So let's save once again, head back to Unity. And as I said, it's still worth pointing out that even if we try level 2 now, it's still going to respawn us in level 1 because we've not followed that sequence. Sequencing is, it's so important. It's so important. So, yeah, once again, let's collect all 5 coins. And now we should head to level 2. Excellent. So if we pause and click restart, it will indeed take us to level 2. Cool. And let's quit to menu, and it does take us there. Now, if we press play game, it will take us to level 2. So in a lot of ways, this is kind of, let me stop that there. This is kind of a very base foundation for saving and loading, which is what we're going to go into next tutorial. But realistically, we don't want to be able to go to level 2 if we quit to menu. We want to go to the first level at all times on play game. So what I think we need to do is whenever we quit to menu, we always need to set the number of what level we're going to back to 3. So let's go to our pause. And whenever we quit level, let's have the global level dot level number equals 3 and save. And now that will mean everything is cycling perfectly through our game. So obviously saving and loading is vital in a lot of games, and you don't necessarily have to have this feature in your first game if you don't want it. I just figured it'd be a nice thing to kind of teach, and if you want to use it, you indeed can. So we are going to use something called player prefs to save and load data in this game. So when we get to level 2, I want to be able to save the fact that we have reached level 2, so when we load, we can indeed start at level 2. So in order to do that, we need to go to our main menu. And in here, we're going to declare a variable. That variable is going to determine what level we actually are going to go to when we click load game. So let's have public integer, so int, and we'll have this as load level. Now what we need to do is we need load level to be pulled from, like I said, a player pref. And a player pref is a way of storing information even when Unity has been closed. So you could think of it as an internal save file logically. So we can say load level equals player prefs dot get int, and in brackets and quotes, this can be absolutely anything. You can name it anything you want. It's probably wise to name it something sensible, I guess, but if you wanted to call it, I don't know, subscribe to my channel lol, then you could, but it'd be a very silly thing to do because it's nothing to do with YouTube, nothing to do with subscribing, and nothing to do with lol. So I'm going to call it level load num. And let's close the quote, close the bracket, and semicolon. So at this point, the first time this ever runs, that player pref load level num is going to be 0. So we need to now have an if statement to control whether that should change or not. So if, in brackets, load level is less than 3, because if you remember, 3 is the very first level that we have, then all that's going to do is take us to here. So I'm going to copy that line of code and place that there. We now need an else statement because we're saying if that isn't the case, if it's 3 or above, then we do the same kind of thing, except instead of a global level dot level number, we change that to load level. But before even that, we actually do need to change the global level number to whatever number is in our player prefs. So what basically we're doing here is we are loading up this particular number and we are telling the game, here, this is the number, store it while we play the game. Because even a static variable will forget its information once the application has been closed or once you've stopped playing the engine. So we do need to tell it what that number is. So we do need to say global level dot level number equals load level, semicolon, and save. So it's incredibly vital to put this in there because without that line, the problem you have is that the global level script has no idea what level you're actually going to be on. It has no idea what the save number is. So I know it's crazy to work on loading before we've even worked on saving, but trust me, this way is much easier, surprisingly. So we now have the load feature in place. We now need to put the saving feature in place, and then we need to make this button work. So let's head back into Unity. Let's let it refresh. There we go. And now let's go to our level complete script. So this is going to be the script which allows us to control what level we are going to be on. And once again, we can actually use this particular line of code. So this is where the saving feature comes in. We only want to save once we've actually completed the level. because if we don't complete the level, there's no point saving it. So let's say that player prefs dot set int, not get. Remember, the last one was get because we're retrieving. This one we're setting because we're telling the player pref this is what we want to do. So we need to now put in here the name of that player pref. And I've always found the best thing to do is to actually copy the name of the player pref, like so. The reason being is because there's been many a times when I have typed, I've had a little typo and something hasn't worked properly. By copying and pasting, you're ensuring that everything you type is exactly the same. So that is identical now. So we're saying that that particular player pref needs to be loaded with global level dot level number and semicolon and save. So let's run through what exactly is going to happen here. So we're in level 1, we've completed level 1, and it's telling us that we're going to scene number 4. So at the same time, we set the player pref of load number to the value of 4. So if we quit out now, if we stop the game and come back into it, we will actually load into scene number 4. So obviously it's very handy. And saving and loading is something, in this sense, very easy. Obviously in bigger, massive games where you need to save much more information, it's done probably slightly differently. But for all intents and purposes in a game like this, using a player pref to save is the most easiest and best option. It's also very convenient. So let's head back into Unity. And we don't actually need to do anything just yet for it, but we do need to add to the load button that script. So let's go to load button. Let's click on the plus. And now we need to drag the menu control over here. Click on no function, global level, and we need to select, sorry, it's main menu, isn't it? Main menu and load game. There we go. So whenever we press our button now for load game, it will do one of two things. It will either take us to the beginning level, or it will take us to the level that has indeed been saved in our player pref. So we need to make sure all of this works now. So we know play game works. That will take us to the correct place. Let's try load game. Obviously, because there's no data to load, it will take us to level 1. And it will infinitely take us to level 1 no matter what. So, next thing to do is let's test that it will indeed load the next level. So let's go to play game. Let's complete level 1. And then hopefully we can load up level 2. There we go, level complete. Perfect. So let's say we've got to go back to our main menu. Let's quit. Let's try this again. If we go to load game, straight into level 2. And that works even if we stop the game, even if we closed Unity down, pressed play again, and click load game, it indeed takes us to level 2. And that will work constantly throughout. So even when we get to level 3, level 4, level 5, level 6, you will see all of that happening. It will save it each and every time, because the key line of code is this one right here, where we're always setting the integer to load from the player pref. So you can hopefully see the cycle that happens here. Whenever we complete a level, it tells that player pref that we've done it, and this is the level for future reference. Here as well, it does indeed keep it so we can see. So between these two scripts, this line of code and this one, we're always setting that player pref to be the correct value. Now, one thing I will also say is that in this case, if we play game now and go to level 1, and if we quit to menu and load game, it will still take us to level 2. Now, this will only happen once. So if you've got a game with, let's say, 10 levels, and you've loaded your game on level, let's say 5. Quick back to menu, obviously you'll load back into 5, and if you press play, the start button, you'll go to level 1. If you complete level 1, your save will be overwritten. And you can get around this to some degree. All you need to do is just use multiple player prefs if you want to. That's the quickest and easiest way of getting around it. But like I say, for all intents and purposes, all of this will work just fine. So we actually have 2 levels up until now. And depending on what you want to do, how quickly and easy you want to create things, you can once again, as we did with level 2, duplicate. Now I'm quickly going to take about 2-3 minutes to build the 3rd level, link it all together, and just quickly demonstrate how easy it is now to have everything working. So we have our 3rd level there, we can load it, we can play through to it, we can do everything we need to. So once again, let's quickly differentiate between all of these levels. I'm just going to have this one as, let's have this as a green one. It's nice and quick. So let's get some more materials. Green material. And let's have it as a nice darker kind of green maybe. There we go. And let's quickly apply it to everywhere. Like a green screen, I guess. And let's move some of these obstacles around just for good measure so we can see that the level is once again different. So this in the corner there or something. Coin over here. Let's move that there. A coin there. Okay, so that is definitely another level. So I'm going to save that. Let's go to File. Let's go to Build Settings. Let's go to Add Open Scenes. Remember, it's still following that sequence of numbers. So 3, 4, 5. So when we get to the end of level 2, it'll add 1 to there. So we'll end up going to the next level. So it really is as quick and as simple as that. We're done. We could actually play through this to the 3rd level now. However, remember, if we get here and try testing, things aren't going to work properly because we're still not in that sequence. Obviously, that just comes down to a little bit of debugging if you need to test for any particular reason. So let's quickly make sure all of this works, and then we are going to work on our main menu with that randomized hint text. Now that's kind of cool. So let's play our game. Let's do this super quick. Because if this now works to get to level 3, then indeed it will work with everything. So any further levels that you create, it will work. So that's 1 coin. 2. In hindsight, I shouldn't have spread them out quite so much, should I? It would have been quicker. Okay, so now this should take us to level number 3. And awesome, we are on the 3rd level. So let's quit back to our menu. Let's load game. And we load level 3. So it really is as quick and as simple as that as creating more levels. So if you just want a quick run through of a game, you want 100 levels all in that style, you could do that probably in an hour or 2. Obviously, designing levels takes a little bit longer, but either way, you can use that same process no matter what. So how do we go about that hint text on the bottom of our screen? So down here. Now, this is going to be kind of interesting. So I want to have some text here that randomizes every time we load the game. So let's start by adding in a text box. So UI, let's go to text. And let's have this anchored down on the bottom right. And obviously we need to make it a little bit bigger. So let's take our rect tool and expand to probably about there. Let's have the text as white. And I think it needs to be quite a bit bigger. So let's have this as size 50. And center on the alignment. In fact, I'm going to have it, I'm going to bring it out a bit more. So I'm going to have it starting there, and let's put it completely blank. So now let's go to our main menu script, which is right here. And this is all going to be done inside the start method. So let's add that back in. So void start, and it doesn't actually need to be private, so that's completely fine. Let's also add in a variable for the text box and a variable for the number that we're going to randomize to select a certain text to display. So public game object hint box and public int hint num. So whenever the game starts, right here, we're going to say hint num equals random dot range, and in brackets we're going to define a number between 1 and however many hints you want to display. So if you've got 5 hints, what you would actually do is put the number 6. So one of the little quirks about using random.range is that it will never generate that maximum number. It'll always generate 1 below it. So if you have 10 hints, for example, you would actually put 1 and 11. Like I say, it never generates that number. It'll always go between 1 and 10. So I'm just going to do 2 different ones because, to kind of save time here. I'm not going to write 10, 11, 12, 13, 14 different types of hints, but you can if you want to. So because I'm only going to generate either 1 or 2, that number is going to be 3. Semicolon. Now what we do is an if statement. So if hint num equals 1, then we do the following. And we're going to be using some UI. So before we go any further, let's add that to the namespace at the top. Using Unity engine dot UI semicolon, which means now in the if statement we can say hint box dot get component in spiky brackets text open close bracket dot text equals, and we can put anything we want here. I'll put collect 5 coins to complete the level semicolon, and I'm actually going to copy that if statement one more time, and instead of collect 5 coins I'm going to make it say don't let the timer hit 0. And you know what, we'll actually do one more. So we'll change that to 4. So we've got 3 possibilities here. We don't need that random.range again. It's just the if statements. I did not mean to copy that. And we'll get around to the numbering in just a second. This one we'll put don't crash into the obstacles. So we have 3 different hints that we're going to display at the bottom. The first one if it generates 1, the second one if it generates the number 2, and the third one if it generates the number 3. So let's save that. Like I say, if you've got 10, 20 of them, you can just do the same process all the way down. And there we go. It has loaded. So let's go to our menu control, and you'll see the hint box we need to assign. So that text is what we have. Now if we press play, one of those 3 messages will display at the bottom. Don't let the timer hit 0. So let's load the game again. Collect 5 coins to complete the level. And let's see if we can get the other one to appear now. Nope, 5 coins to complete the level. Don't let the timer hit 0. We've had that one. Don't crash into obstacles. There we go. So we've had all 3. So that is a nice, quick, convenient way to display some hints at the bottom of your screen. And you could be fancy with it. You could add some animation to it if you wanted to. It's entirely up to you. You could have it randomize every 10 seconds if you wanted to. All you would need to do is just add in a coroutine to that and just cycle through it every 10 seconds. Again, it's entirely up to you, but realistically, that is as simple as it gets. So at this point, we pretty much have our entire game, or rather the base of our entire game done. It's now realistically down to you guys to manipulate all of this, take what you've learned, change some things, add things in, take things out, and make it your own game. So for most people, when creating their first Unity game, they don't need to worry too much about some of the advanced settings and all the things you can tweak. I think for a lot of people, the main thing is to be able to build the game and then play it. So they've made it, they want to change a few settings, they want to build the actual game executable and then play and get other people to play. So we're going to focus on that in this lesson. Now, I've already gone ahead and imported two textures. One is like a little banner and the other is a little icon. And all these are just little extracts from what we have in the game. You'll notice this icon as our little dragon here, the exact same one. So that's all that clip is. So if we go to Edit and go to Project Settings, you'll see all different types here, and we don't need to worry too much about some of these at all. A lot of these won't even matter for our first game, but ones that will are the player. So whether you're building this for PC, for iOS, for Android, or whatever device, all of this is going to be relevant to some degree, but not everything will be relevant. So let's go through a couple of things which at least should be worthwhile creating. So company name would be whether it's your name, whether it is your developer name, whatever. So I'm going to put JV Game Studios. The product name, in this case, says My First Game, but that could be anything you want. I'm going to call this Dragon Chicken Condor, because why not? And then obviously the version. Now, a lot of the time, version doesn't really matter, especially if this is just a test for you, if this is just something to get you up and running in Unity. But if you want to make a full game out of it, it might be worth keeping note of the version numbers. So if you update it, maybe it would be version 1.1, 1.2, whatever. Now, this is where we start to get a little bit more into what the executable file will look like. We have here a default icon, and all I'm going to do is just drag and drop this here. So what that basically means is that whenever we have the icon on our system, it will be displayed as this. So in the taskbar, in the folder, that will be our icon. Cursor doesn't matter too much, and the hotspot doesn't matter too much at all. It's not really relevant for what we're doing here. So if we go down this list, we're on PC here. The icon will automatically be placed here, which is all good for us. So we can see we don't need to override. I think that will do just fine. Resolution and presentation. It's up to you what you want to do here. So you can see there are many different options that you can play around with here. So if you look at the standalone player options, what that means is that it is the actual executable itself. And you can change, for example, the supported aspect ratio. So you can play any aspect ratio you want. You can see it is ticked, but if you only want it done in 16:9, then just only have that one ticked. Full screen mode, we can see we can change if we want to. It might be worth playing around some of these settings, but you'll generally find a lot of default settings in Unity are pretty good as they are. So next, splash image. Now, this is not the splash screen that we created earlier. This splash screen can be something, at least in old versions of Unity, where you flag up with a little window before you even begin the game. And that image on there was the splash screen. So in case you do want to use that for any reason, that's what I have that banner icon for. Now, a couple of different things here. I mean, you can see splash screen there. You can see that is the Unity one. Remember when we actually created that splash screen? When we click preview, we can see that's what I mean. We'll always have that splash screen before anything else. And that's just a quick demonstration of what it was. And obviously you can change that if you want to. It's entirely up to you. Again, if you are using the free version, you don't want to pay for the seat or the license, whatever you want to call it, then yeah, you will have to have that by default. There's obviously different things that you can play around with if you want to, but generally everything should be okay. When we come down to the other settings, I don't think you really need to worry about any of this at all. Like I say, especially for the first game, just don't worry. You can play around with it if you want to, but the end result of what we're going to get when we build this game is going to be pretty decent as it is. Obviously, that comes down to a Windows build. It's all going to be the same here. So if you're aiming for this, play around with some of these settings if you want to. But again, the ones we've already entered now, that's pretty much where we need to leave it. Again, if you're doing this for iOS, for Android, yeah, same things apply there. Next thing I want to go into is the quality. So generally you'll find everything here. People can select their own quality levels. You can even add your own. You can rename them if you want to. Again, I've always found that keeping this as it is a really good base for Unity anyway, so I wouldn't worry too much unless you want to rename a couple of things. One thing I do actually want to touch upon in the end, before we actually build the game, is do you remember when we created the timescale for pause? That's where you can actually set the real time level. The timescale, like I say, is always 1. It's always best to kind of leave it at that, but if you ever want to change it for whatever reason, yeah, it's right there. So we've got our game, we're happy with it, everything is good. Let's build this game to play for real. How do we do that? Well, let's go to File, let's go to Build Settings, make sure everything is okay, we're on the platform that we want, and we can either press Build or Build and Run. So pressing Build will just prompt you to save the game in a specific folder. Build and Run will do the exact same and then instantly run it whenever it's built. So let's do that. Let's go to Build and Run. I'm going to create a new folder. It can be, well, call whatever you want. And then select folder, and the game will indeed start building. So while it's building, let's discuss where we go from here. So we've built our game. We're happy with it. It's looking decent, I guess, for a first game. What can you do with it? Well, if you want to let people play with it, I would recommend somewhere like Itch.io. Itch.io is a great platform where you can upload your game and get people to play it. Obviously, there's other places like Game Jolt, there's Steam, or you can just let people play it whenever. And as you can see, we're straight into the game. It's that quick building it. And gosh, we'll discuss a little bit more where to go from here. I didn't think it would build that fast. Okay, so already we can see a couple of things that do need changing. So building a game always gives you a great opportunity to see where problems lie in your game. And already we can see that this is misaligned, so that just needs a little modification in Unity itself. Let's play game, see how it looks. Yep, everything seems okay. I'm happy with how it looks. Let's resume game. Cool. The score does look like it's gone a bit astray there, so not the score, the time. So that again is something that we probably need to modify. Let's head back to the menu. Let's load game. Yeah, so everything seems relatively decent. And finally, let's quit game. Excellent. So everything is relatively okay there, and it did look like we have a couple of bugs, but that is just something that you work out here. That's all that would need to be. So we probably need to have this stretched down the bottom rather than the center. That will mean that our text should be okay. It should roughly display in the right place. If we go to our scenes and let's go to level 1, let's save that. So all that will mean is just quickly moving things to the correct place for our time. You can see that our anchoring for the time is still over in the top right. So let's select those and set it to the top left and save. Let's head to level 2 and do the same. So it's always a good idea to kind of play test things sooner rather than later. So at least you've got an idea of the errors you have to deal with and the bugs. Because if we'd have built 100 levels and that would have happened with time, that would have been a bit of a nightmare to kind of fix. But we've got through it. So we can always rebuild and rerun if we want to. So I've just selected build and run straight from that file menu there. So anyway, to add to what I was saying, where you can upload the game, if you want to learn more, I have tons and tons of tutorials on my channel, loads of stuff to learn. There's tons of assets and great things out there. So yeah, it's all about what you want to do next and how you want it to look. There we go. So that's that fixed. Let's get to level 2 again. Okay, so we have gone to level 3 there. So we've just come across another bug. Now, this is probably something that we will have to fix. So the reason that has happened is because although we've gone to the first level. We have ended up in the third level after we've completed it, simply because of what has been loaded into the game. So if we go to our main menu, and if we go to the menu control, and let's go to main menu, script. So remember down here, that is where we get the player pref. So we load it in there. So currently the player pref will be 3. Now, when we've clicked play, we have indeed done what we need to, but there is one extra thing that we should have really done when we have clicked play, and that is reset everything. So when we click start game, realistically, we need to put global level dot level number equals 3, semicolon, and save. So like I say, also going from here, you'll find yourself in and out of building the game, trying to correct little bugs that you come across. That little bug has now been fixed, so if we build the game and ran again, we wouldn't have any issue with it at all. See, as I was saying, if you want to upload it, try Itch.io or GameJolt or somewhere like that. I have tons of tutorials if you want to learn more. The Asset Store is a great place to take a look for different things. We use the Asset Store to get the characters that we have in this. And yeah, generally, if you want to know more, leave a comment. And yeah, I want to thank you very much for sticking with me for, I think it's just under 5 hours now that this series will have been going for. So yeah, thanks for sticking with me. Thanks for learning. And I'd love to see what some of your projects look like right now. So hopefully see you in another video. Thank you very much for watching.